Share the meeting.
Prithvish, can you please check with Bhagat?
Cognizance Rurki is here.
Yes, so if you want, then you can also get the recording of the session.
Good, good. Thank you. Yes, we do want. Okay. Pranav is saying that he can't log in because he needs a panelist password. Do we know what it is?
I also sent that to you, sir.
I'm putting into one-to-one Slack with you, Vijay. Just give me a second.
Okay. Neha is there. Hey, Neha.
Vijay. Hi, everyone.
Okay, good. Okay, good. Hey, Pratik.
Hi, DJ. Hi, everyone.
Thanks, Prithvish.
Prashanjit.
Oh, huh.
Camera, huh?
Yeah. So,
Hello.
so like everybody's here now.
Sure.
So, what's the name of the person who's from Adi Roorkee? Hello, host.
Hello, sir.
Hi. No, okay. What's your name? How do I address you?
Sir, this is Aditi from IIT Roorkee.
Aditi. Okay.
All the participants are still joining, so sir, we can start at in 5 minutes.
Okay. And we have one more person from our side about to join.
Okay.
Hi, Pranav.
So somehow I got logged out, but I'm back.
I'm sorry. Can you hear me?
Yeah, we can hear you, Gaurav.
Okay. Okay.
DJ, it's 11. Shall we start or wait for some time?
So we will start in 5 minutes. Participants are still joining.
Okay.
Yeah, it's just 62 now. So hopefully in 5 minutes, we'll have little more, at least 100 we are expecting shortly.
Yes, sir, sure.
Sunday, so
So we should start now as other participants will also join later. So let me start with the intro. So first of all, a very good morning to the speakers from Third Eye Data and all the participants. I, Aditi Govil here, Senior Executive at Cognizance IIT Roorkee, heartily welcome you all here to the workshop on solving real-world problems with AI computer vision by the Third Eye Data, which delivers end-to-end data and AI solutions for enterprises worldwide by leveraging state-of-the-art data and AI technologies. Third Data has over a decade of experience in transforming enterprises like Walmart, Microsoft, Southern California Edison, British Petroleum, and a host of large and small companies worldwide. So let me introduce to the speakers of today's workshop to you. So we have DJ Das sir, who is the founder and CEO of the workshop of the Third Eye Data. He started US career working as a software developer in Microsoft and Sable Systems. We have Aprajita ma'am, who is the co-founder and chief delivery officer of Third Eye Data. She has 25 plus years of industry experience. We have Pranav Ghosh sir, who is the chief data scientist in Third Eye Data. He is the owner of multiple open source big data and data science projects. We have Vishal Yadav sir also. We have Vishal Yadav sir who has full stack lead here in the data scientist Third Eye Data company, and Neha ma'am having data scientist lead at Third Eye Data, Ipshita ma'am data scientist at Third Eye Data. We have Pratik Ghosh sir, senior data engineer, and Prasanjit sir, delivery manager, and Punima ma'am, who is the HR manager and coordinator. So I, on behalf of the Cognizance team, welcome the speakers and thank them for providing us with their precious time to enhance our knowledge. So, sir and ma'am, the stage is all yours. Thank you so much.
Thank you so much. On behalf of Third Eye, we welcome all the participants on this workshop and sincere thanks and gratitude to Cognizance IIT Roorkee for supporting us, and a huge welcome to all the participants. It's a Sunday, so you took your time to join this workshop. We will begin it welcoming our CEO, Mr. DJ Das, for his introduction speech for the session. Welcome, sir.
Thank you so much, Prashanjit. So, hello everybody. Thank you so much for joining this workshop today. I know it's a Sunday morning and it's a Saturday evening for me here in California. So, so I'm still, it's like 10 o'clock, 10:30 at night, but still I'm here. So today's workshop is going to be a little bit of a unique workshop. And as we said in the landing page of the workshop, and that is, this workshop is going to actually showcase to you how a real world AI project actually gets executed. It's not as dreamy as you might really think an AI project would be. It's not just AI, it's a lot of things that come together to deliver an AI solution to an enterprise client. So wanted to quickly go over the deck to showcase to you about a little bit about Third Eye so that you understand our background and what we actually do. Who are we? We actually transform enterprises with data and AI solutions. We started life 10 years ago, where we were implementing a lot of big data solutions here in the Bay Area, California. I've been a resident of California for the last 28 years and been working with a lot of startups, with a lot of big companies, everything in between, whatever works out in California. So Third Eye started life as a big data implementation company, but over time, we have become a company that delivers end-to-end AI solutions for our customers worldwide. So primarily, we make sure that an enterprise can take data-centric decisions through data processing. We are the data geeks. We love to work with data. We are very hands-on with data, and we make sure that enterprises can benefit out of the data assets that they have across the enterprise. Our main service areas have been data sciences, data engineering, where it involves end-to-end data lake, data pipelines, data analytics, and everything else that's needed to prepare the data and get it ready for a data science project. Of course, we are in all the clouds that are currently available. We also have done in the IBM cloud too, in addition to these clouds. So we are, over the time, we have been able to address a lot of industries, but this is the main slide that I wanted to really talk about. We have been fortunate enough to have worked for so many different companies across the world. In the US, these are the companies for whom we are directly working. We are a direct vendor to all these companies, and we would be talking to you a little bit about the various projects that we've done for these customers here in the US. Microsoft has been our customer right from the beginning. So just for an example about what we do for Microsoft, as you know, Microsoft has been releasing a lot of new technologies almost on a quarterly basis. But we take those technologies, we create a solution out of those technology. It could be a solution for any various kinds of industries. It could be a solution with many different kinds of use cases. But that solution is then available for various customers of Microsoft worldwide. So that's our contribution to Microsoft's technology stack and how they could kind of stitch together all these technologies into solutions and deliver it to the customers. For companies like Walmart, Southern California Edison, operator will be talking to you in detail about those projects too. And in case if you have any questions about the kind of work that we've done for other customers here, please feel free to get back to us. We'll be more than happy to talk to you guys about the various projects that we're currently running at Third Eye. Over the time, we have been able to work for many different companies. For example, Glass Trotch, they are based in Switzerland. We have finished up a good project for them where we were doing some AI ML work for the glass manufacturing process. Very interesting project that we did for them. So all in all, I would like to now bring in Operator Das to talk about the different projects that we have been working here at Third Eye.
Hello, everyone. I hope you can see me. So nice to meet you all, and good morning. And I'm Aparajita Das. I go by Jita. So I'm in LinkedIn. Happy to connect. So let's go over a few of the projects that we have worked on, right? Here, it is Walmart. But even it's a Walmart, you might be thinking, what kind of computer vision work have we done for Walmart? So we brought this project up for you to emphasize that data engineering in analytics world or AI analytics world is very important. So for Walmart, the project started, I think, several years back, but it's still continuing. Actually, our team is still working on this. And in here, what we primarily work on is, I would emphasize, is on a daily basis, minimum 8 billion rows we process. How long does it take? Around 8 minutes. So that's the charm here, right? So the volume and variety, without going into the detail of the use case, so 8 billion rows. This is ad world data, ad tech data. So impressions, clicks, conversions, transactions, how much money Walmart makes from those ads, right? That's what we measure. And so 8 billion, say, impressions, if you're talking about, then you have to join to respective clicks, right? Join to respective conversions, transactions. So then, say Walmart kind of companies, they have the app, and they have the website also. So these ad clicks could come from the mobile app or from the website, right? How do you track them? Who clicked on which ad, and because of which click actually Walmart made money that day, right? That's what is the that's the measurement we did do in this project, right? So now in terms of technology stack, right? First of all, I am emphasizing again in this project, we have to love data, right? Here, if we talk about, say, structured data, for example, but it's pretty huge in volume. So we use Google's BigQuery. So BigQuery, I'm a big fan of BigQuery, but at the same time, say BigQuery will, process structured data. For example, there are many creatives, right? In ad world, there are creatives. So which creative is actually effective, which is not effective, right? So there a lot of AI can be used, and we are using that to do measurements, right? Just a little bit, a glimpse of it I just gave here. So here, a lot of data that we process within very short time span, and we give the analytics, right? So that they can decide on which ad to place for the maximum conversion later on. This is another project that we are actively working on. This is very related to today's topic. It's around computer vision, right? You will see a lot of content around what we have actually worked on for this project. So basically, Southern California Edison, they supply electricity to Hollywood, Disneyland, and all in Los Angeles area. So as in India also, right, you see the electric poles which transmit electricity to supply to regions and homes, and same way in US also there are electric poles. In some areas these days we have underground, but we are talking about electric poles here. And as you know, electric poles can leak electricity and which can catch fire, right? Or electric poles need maintenance. So in olden days, human used to go and climb up the poles and look at the health of the poles and so on, right? And that way they used to do maintenance. But in Southern California Edison, what they do on a daily basis, minimum 100,000 images are taken of all these electric poles, and those images are sent back to cloud storage. Now they have inspectors, human inspectors, and they will go through 100,000 images on a daily basis to check which electricity pole might need some repair. You can imagine that's really time consuming and it's very expensive. They need a huge team. So how AI can help? So that's where we worked on it. So basically the images using AI, various algorithms, Neha, Vishal, Pranav, they're there also. We'll go over it. And I was part of the project as well. So these images are automatically read, right? If you think there is a computer vision one algorithm reading this image and telling which electric pole is broken or not broken, that's not what the case is, right? That's not the way the problem is solved. The problem is solved by common sense, and basically it's a flow of algorithms. We use ML, we use neural network, we use mathematics, we use common sense, and we basically design a workflow. And in the workflow, we plug in the algorithms, respective algorithms or math as needed, right? So you will hear a lot about it. So this project is real world problem solutioning using computer vision. So I think I'm almost time's up. And if you want to know more, happy to share. Connect me in LinkedIn. We will really go into detail. A lot of good things happening here. Yeah, over to you. Thanks.
Thank you so much, Aparita, for that explanation. So do you want to quickly talk about the ebook?
Oh, sure. Yeah. So here is an ebook. If you are interested, we can give you the link. So the 5 stages of becoming a data-driven enterprise. So this is a very popular ebook. DJ and me actually, we write at times. So I'm happy to share with you all. So what this book does will give you is for any enterprise, right? Say any enterprise, they have data, right? But if they want to leverage data to know how their business is doing and grow the business using insights or analytics, right? So then this ebook will give 5 simple, easy steps, right? So that's all about, and we'll share the link for you. Yeah.
Thank you so much. So yes, so the main point that we're trying to make over here is that you have to love data to become a good data scientist, to become a good data engineer. And it's just not one skill set that actually enables you to become a good data professional. You have to know about a lot of technologies because they all come together to create a good solution for the enterprise. So this ebook that Operator wrote, it mainly enables a business to understand how to become a data-driven enterprise. Because typically what happens is somebody would have some idea and then they want to do something data-driven projects. But it doesn't really work out that way because you have to prepare the company. You have to do a lot of data assessment, data quality checks, so many more things to get the data ready to perform any kind of analytics. So this book goes into those details. So yes, I saw some things coming up about sharing the link to this ebook. Yes, we'll be sharing it right now. And all in all, we just wanted to kind of emphasize the kind of work that we do here at Third Eye, and more than happy to discuss with all of you about our journeys going forward. Thank you so much, everybody. Over to you, Aditi, Prashanjit.
Thank you. Thank you so much. Lovely meeting you all. So proud of you all. You guys are doing awesome. And you're showing interest in data, and data is new oil. So you are in the right spot. Yeah. Good luck.
Thank you so much, DJ. Thank you so much, Aparajita, for this wonderful informations. And guys, this is very important, right? We are all tech savvy, but how you become tech ready? And this session is going to give you this value. And this ebook is exceptional. Of course, we'll be sharing the links with all of you. And we really look forward to know a lot from you, what are your interests are. Now it is my privilege to call upon Mr. Pranav Das, lead data scientist
Pranav
for
Ghosh.
his Pranav Ghosh, sorry, Mr. Pranav Ghosh for his part.
Okay, let me try sharing my screen. Oh boy. I'm in trouble. It's not letting me share my screen. There is some security. Does anyone know on Mac?
Yeah, I'm on Mac, so maybe then I can share the screen while you can speak.
Okay. Okay. You want to bring up my content?
Yeah, I'm going to share the screen right now.
Okay. Yeah, I thought I went through this here last night, but I probably didn't.
Okay. Yes. I think all of you can see my screen, right?
Yes,
Yes, sir, it's visible.
Okay.
Pranav, carry on, please.
Okay, so welcome everyone. So I'm just going to talk about deep learning as it relates to vision problem. We'll talk about deep learning in general a little bit, and then quickly dive into the kind of problem deep learning solves for vision and the solutions.
Pranav, sorry to
Yeah.
interrupt. Would you mind giving a bit introduction about yourself?
Okay. Yeah,
Yeah.
I'm the chief data scientist for Third Eye Data. I have more than 35 years of experience. I'm a graduate of IIT Kharagpur and then MIT. I have worked for various companies of various size. Worked for most of the big tech companies in the Bay Area. For about last 15 years, I've been working as a consultant. For about last, I'd say 5 years, my focus has been mostly machine learning and AI related problems. I own several open source projects in GitHub. Very active blogger. I blog, once a month. Write some in-depth article. Very active in social media also, LinkedIn especially. Large number of followers, and if you want to connect with me, feel free. So with that about me, let me jump in to what this deep learning is all about. So this is the agenda. So I'll talk about deep learning basics a little bit. So most of the discussions will be at a very high level, conceptual level. I'm not going to go into details of some specific algorithm or get into maths or other technical details. It will be very much at a conceptual level, just to kind of give you a roadmap of what deep learning can do, especially for vision problems. And then some of the cutting edge work that's happening and the future directions. So with that, let's go to the next page. So deep learning, I'm sure, these days deep learning has become kind of synonymous with AI, but it's actually not. So machine learning is part of AI, and then deep learning is I would say, one area of specialization within machine learning. So machine learning is all about learning from data. Technically, it's called inductive learning. So you're essentially learning patterns from data, as opposed to classic AI, where that there are a lot of activities with classical AI in the 80s and 90s and 70s. Essentially involved in symbolic logic, and it's kind of top down, whereas machine learning is kind of bottom up. It's all data driven, inductive learning. So deep learning is a kind of machine learning solution. It's inspired by the architecture of our brain, although we shouldn't have any illusion about deep learning networks being comparable to the complexity of the brain. It doesn't come anywhere close. It solves many practical problems. That's one thing good about it, but it shouldn't be associated with human level intelligence or human level cognitive skills. Although a lot of people make all kinds of claims, but it's just false. It's a very powerful engineering tool. Essentially, it performs statistical correlation in very high dimensional space on large amounts of data, which you cannot do with any other technique. So that's where its real power comes from. And it solves many real world, complex problems, which cannot be solved by any other technique, especially especially suitable for any kind of natural data, high dimensional natural data. For example, vision, audio, then language, video. So that's the kind of data where deep learning really excels. If you have regular business data like tabular data, deep learning is probably overkill. You probably don't need it. It's really shines with very high dimensional, natural data, and most of the applications are actually with those kinds of data only. All right, next one. Next slide, DJ.
Yeah, Pranab, I will have Prashanjit share. So I'm going to stop sharing and Prashanjit will go on the next slide. So
Sure.
Prashanjit, over to you.
Sure, absolutely.
Okay, so next one. So some terminology. So in our discussions, we'll be often making reference to various kinds of networks, and these are the acronyms. MLP is just a regular feed forward neural network. CNN is convolution neural network. It's used mostly for image problems. although there are some applications for text problems also. RCNN is a special kind of convolution neural networks where you want to identify multiple objects within an image. R stands for region. So essentially, it identifies the bounding box as well as the object within those bounding boxes. And there could be multiple of those in an image. RNN is a recurrent neural network, mostly used for sequential data, like language. Language is sequential data. LSTM is similar to RNN, but more sophisticated. Actually, RNN came first and then came LSTM, and even LSTM has been kind of superseded by something called transformer. Then GAN is generative adversarial network. It's this is something very unique. Most of the networks that we see here, they are all used for predictive task or where you want to make some kind of inference. But GAN is a kind of network called generative network. They essentially, their job is to generate data. So all these, fake videos or fake images that you see on the internet, they are generated by this kind of network called GAN.
Okay.
So, anyone has any question? Okay, sorry. Then transformer is something very recent. It can operate on, actually it started off with being applied for language problems, but it's gaining ground for vision problems also. So it's slowly replacing convolution CNN for vision problems. And those networks are called vision transformers anyway. So it's kind of the state of the art in deep learning right now, transformer. I don't know if you have had this news this week, there are big news, deep learning news. One was a language model from Google called, what is it called? Anyway, I forget the name. Anyway, and then there is a vision model from OpenAI, and they're both based on transformers. The vision, vision generative. So you can kind of create an artificial artworks from OpenAI. It's called Del.E, that's the product. So they are all based on this transformer, which is a kind of network. Anyway, let's go to the next page. So as I said, it mimics brain somewhat, but in a very simplistic way. It doesn't come anywhere near the complexity of brain architecture. I actually spent, out of self-interest, I spent a number of years studying the architecture of brain and neuroscience and all that. It's really fascinating. So it doesn't come anywhere close to that, but it's a very simple-minded, model of brain. So essentially what you have is you have layers of neural units and they are connected. So each layer is connected to the previous layer. It takes input from the previous layer, does some processing and then passes the data to the next layer is the input. So you have multiple such layers, and then at the output of the final layer is the output of your network. So the input is fed at one end, and at the other end you have output. So for example, if you want to do image classification, the way that will happen is you'll have a CNN network. Then your raw pixel data will go as input to one end of the network. And at the other end, let's say you want to do some classification, and let's say you have 10 different kinds of objects you're classifying. So there'll be 10 outputs at the other end, and each one will have, it'll output a probability value. So whichever output has the highest probability value is the corresponding label is the label for that particular image, or in other words, that is the prediction for that image. So you may have images for, let's say, 10 different kinds of animals, So there'll be 10 outputs, and each one will have a probability. So you just pick the one with the highest probability. So that's your output prediction. So as far as math goes, all these networks are essentially, lots of matrix transformation, linear algebra, because the output of one layer goes through a matrix transformation, and it becomes the input to the next layer. Actually, after the transformation, it goes to something called a nonlinear activation, and then that becomes the input to the next layer, and so on and so forth. So it just, keeps repeating. So that's the, at very high level, what the deep learning networks do. And most of the layers in the deep learning model, most of the layers are essentially doing feature engineering. So they take some input. So for example, for image, where you feed in, raw pixel data, as the data gets processed through different layers of convolution, it extracts higher level features of the image. So it might extract some line, it might extract some shape. If it's an animal, maybe the shape of the ear or the shape of the head. So it keeps extracting higher level features. So what the network is doing essentially is most of the network is busy extracting all these features. Then at the very end, it makes some prediction, based on very high level features that it has extracted. And it works the same way, whether it's image or whether it's text, whether it's audio. Essentially, that's what it does. It does a lot of feature extraction or feature engineering in most of the layers, and then at the very end, it makes some kind of a prediction. All right, next one. So this kind of network, if they have at least one or more hidden layers, they can approximate any function. So that's why this deep learning networks sometimes are called universal function approximator. So you can think of that as a function approximator, just like you do linear regression, except that this is happening at a very high dimensional space. But the basic operation is some kind of function approximation. And so what happens is, so the data flows, there are two flows. One is forward and backward. So it flows forward, and then at the end, when you get the output, and then we have a network output, and then we also have the actual output that we know, because we have some training data with some level, right? So the difference is the error. So what happens next is that error is actually flowed backwards towards the input, and that error is propagated, and the network weights are updated, based on the error value. So that's essentially the learning process in deep learning. And this process of the error flowing backwards, it's called backpropagation. So that was a major breakthrough in deep learning technology, this backpropagation and how to propagate the error to adjust the weights. And that has an analogy to human brain, where the synaptic connection strengths, they get adjusted as we learn, as we grow, and as we learn. The same thing happens in our brain also. Although the mechanisms are not identical, but something similar happens in our brain also. All right, next one. Next one, okay. So what are the different learning tasks in deep learning? So the most common one is called supervised learning, where you have some data, and you have some label for the data. For example, you have an image, and then the label is what kind of image it is. for, going back to the previous example, which, so the label in this case might be what animal, that image is for. And so essentially it's because you have this label, it's called supervised learning, because we are providing that label, and based on that, the network learns. In unsupervised learning, we don't provide any labels, and the goal is not so much prediction. It's learning about patterns in the data. And there are many usages of unsupervised learning. So in classic machine learning, for example, clustering is a unsupervised learning technique. In the deep learning world, one example of unsupervised learning is something called autoencoder. So the way that works is that you have some input, and you want to learn some internal representation of that input. So that input goes to a network called encoder, and that encoder output goes to another network called decoder. And the decoder is supposed to be able to reproduce the original input. That's the goal of the decoder. So that's unsupervised learning. In self-supervised learning, it's similar to supervised learning, except that there's no label, but it will use part of the data as the label. So for example, in many language tasks with transformer, what they do is they'll take some text and they'll mask some of the words in the text, and then train the network to predict that that particular word that has been masked. So this kind of learning is called self-supervised learning, where we are not providing any label ourselves. The data kind of learns from the data. And this is extremely powerful in deep learning. It's used a lot. Most of the language and vision deep learning models, they all use self-supervised learning. So for example, there is a pre-trained language model from Google called BART that uses self-supervised learning. It's extremely powerful. All right, next one. So these are some of the tasks, vision tasks in deep learning: the image classification, then identifying multiple objects in an image, image segmentation, image generation, image caption generation, which is basically given an image, it will generate the caption for the image. Then image generation from text. So you provide some text, and so for example, you say dog, and you provide the text, this is a dog, and it'll generate an image for dog. In fact, the deep learning model that I just mentioned about, called Del.E from OpenAI, it was, I think they announced a few days ago. So that's what it does. And it's pretty impressive if you look at some of the images. It's all over the internet, actually, last few days. Then image anomaly detection is detecting anything unusual in image. So that has a lot of interesting application in medical and few other fields, manufacturing. So these are some common, vision tasks, that can be solved by deep learning. Let's move on. Object detection is we have an image and we want to classify the image. We talked about it. So there's a CNN network with multiple convolution layers, followed by a dense network, which is a regular feed-forward network, which does the final classification. So the convolution operation is nothing but it's like a filter which operates on a patch of image, rectangular patch of image, to produce feature values, and then those values they go through a nonlinear activation, typically or rectified linear unit ReLU, and then that output goes to a pooling layer, which is essentially downsampling, and then that final output becomes the input for the next layer. And this convolution filter weights are learned through training. So again, this goes through that back propagation, and typically training involves taking some data and then creating multiple batches out of the data, and then feeding the batch, repeatedly and over again through the network. So each object in that batch, it forward propagates through the network and then backward propagates, and then while it's backward propagating, the network weights are updating. So in typical training process, you track the the error, and when the error goes below some acceptable level, you decide that the network has been trained and it's ready to be used. All right, next one. So here, the task is a little bit more fine-grained. So your image may have multiple objects, and this is the kind of stuff that Third Eye has done for SCE, and then Vishal and others can go into the detail. So they use something called RCNN and various version of RCNN. So as part of the training, you have to annotate all the objects with their bounding boxes, and also you have to annotate what kind of object it is within the box. And then you train the model. And after it's been trained, and then so for each bounding box, it will make it will actually do an image classification. And then once it's trained, then given an image, it will tell you what the different objects are and the corresponding bounding boxes. So some of the popular model is RCNN, and then FRCNN, which is faster RCNN, and then there is something called YOLO, YOLO. So these are all for detecting multiple objects along with their bounding box, which is the bounding rectangle. All right, next one. Image segmentation is even more fine-grained. So basically, it's almost like there are multiple objects in the image, and for each pixel, you are predicting what object that pixel belongs to. So this way, you can get the outline of the objects in the image. So it's even more powerful than multiple object detection, because it actually detects the outline. So the network, it actually consists of an encoder and decoder. So the decoder maps the encoder output to object outlines. There are different kinds of segmentation. In semantic segmentations, you just classify the pixels. And so essentially you predict what class a pixel belongs to. Now, sometimes you may have multiple instances of a class, and in that case you need instance segmentation. So for example, in an image you may have two cars, right? So instance segmentation will identify, for any given pixel, it'll tell you which object, which instance of the object it belongs to. So it's more powerful. And panoptic segmentation is a combination of both. It'll, for each pixel, not only will it classify what type of object, but also which instance of the object that it belongs to, if there are multiple. So it's a combination of the previous two. Typically, the networks that are used for image segmentation is RCNN and CNN. So that's what image segmentation is all about. Sometimes it's called scene understanding. So it's like you're trying to understand, if there are various objects in an image, you're trying to understand their semantic relationship. Okay, next. Image generation. So these kind of models are very different from what we have discussed so far. So everything we have discussed so far, their job was inference or prediction. So this one is unique in the sense that it actually generates data. So the task is generative instead of predictive. And so there's a lot of fake stuff that you see on the internet. They are generated by this kind of network, like fake video or some fake image. And so it consists of two subnetworks. One is called a generator, the other is called a discriminator. Now for image, what the generator does is that it tries to generate realistic images with you give it some random noise and it'll generate some image. And the job of the discriminator, which is the other part of the model, is to discriminate between real images and fake images. So the discriminator takes real images as input. As training goes on, the generator learns to generate more and more realistic images, and the discriminator learns to how to discriminate better, between real and fake. So this kind of training is based on game theory principles, as if the discriminator and the generator are two involved in a two-player game. It's a very interesting idea, and so there's a guy called Ian Goodfellow. He is one of the deep learning experts. So he came up with this. It's very powerful. So most of the there are a lot of content generation that's done uses this kind of network. All right, next one. Cross-modal generation. So this is even more powerful. So what it can do, for example, image captioning. So given an image, it can generate caption for you. And obviously you have to train with lots of images and lots of real captions. So it also uses a encoder-decoder pattern. And the networks that are used are CNN, RNN, and LSTM. So the reverse task is given and generating an image, given some textual description. So so this can use the GAN network. So the generator input in this case will be some kind of text embedding with some noise. And the discriminator input will be text and the corresponding image pair. So that's what this model that I was telling you about, that this was announced this week, that's what that does. DAL-E. Given some textual description, it can generate art form, all kinds of artwork, paintings. So this kind of generative models are called cross-modal because there are multiple modalities. There is image and there is also text. So that's why they're called cross-modal, generation. All right, next one. Image anomaly detection is also, it has a lot of practical usage. For example, medical diagnostics, like someone might be taking some X-ray of the chest, and if there's anything unusual, that might be indicative of some medical problem, right? So that's an anomaly because the X-ray will be different from normal X-rays. It can also be used for defect detection in manufacturing. So So this is where, the autoencoder, which is a unsupervised, deep learning model, can be used. So the way it could be used is that, remember, the autoencoder is it has a encoder and then it has a decoder. So, and in this case, both the encoder and the decoder will be based on CNN. So what the encoder will do is that it will take an image and it will generate high-level features from that image, which is the encoder output. And the decoder will take that as input and it will try to regenerate that image. So whatever is the difference between the regenerated image and the original, that's the error. So that's the error that gets used to train the model. So if you have trained this kind of autoencoder and CNN-based model with lots of, let's say, normal images, then you feed in some image with some anomaly, like some chest X-ray or some, picture of some manufacturing parts. What will happen is that once you feed it through the network, the difference between the regenerated image and the original image will be very high, because it's not something the network has encountered before, right? Because it's different from all the normal images that you use for training. So when that regeneration error is high, you know that there's something unusual in the image. So that's how anomaly is detected in images with autoencoders. GAN also can be used for anomaly detection based on the difference between the image and GAN generated images. So you can generate lots of images to the GAN, and then if you find any significant difference between those images and your image with an anomaly, you know that there is something unusual about that image. But autoencoder is generally used, but there are some solutions based on GAN also. Okay, I think that's as far as the different vision tasks. Let's see what the next slide is. Oh, transfer learning. So these models are extremely expensive to train. I mean, it might take, if you have to train them from scratch, it might take several days, running on some GPU cluster in some cloud somewhere, right? And it might cost like, millions of dollars to train this model. So it doesn't make sense for everyone to train this model from scratch. Fortunately, some of the big tech companies, they have trained these models and they have made them publicly available. So, and actually, Third Eye has used one of those trained models, but you cannot use those models as is. You have to do additional training. So you take one of those models, and what you do is for your particular domain specific data, you do additional training, except that during this training, you train only the last few layers of the model. Sometimes, the very last layer of the model, and you freeze all the remaining layers. So this is called fine tuning. So although the model is already trained, but it's not trained for your particular domain and your particular kind of images that you have, right? So this additional training is necessary. And without transfer learning and pre-trained model, I mean, it's almost impossible to, unless you are a big company with lots of a lot of money and a lot of resource. Most people cannot afford to train this model from scratch. So I mean, so essentially they will be out of luck. They won't be able to use deep learning models without this kind of pre-trained models that are available for free. So different companies, Google, Facebook, Microsoft, they all have made available, all kinds of, pre-trained, models for people to use, and they're for free, just like open source code. Okay, next one. So this is a very interesting topic, although, like I said, the CNN is inspired by human visual processing, but the human visual processing is actually quite a bit different and a lot more complex compared to the simplistic, CNN model, where you just feed in some data and the output, you get the output at the other end. The human visual processing is a lot more complex. It's bidirectional. It's based on a lot of knowledge you have about the world. So way it works according to neuroscience is that, yeah, I mean, there is the visual signals from your retina of your eyes that gets processed just like a CNN model, but at the same time, higher up in some area of your brain, there is a generative model which is always trying to predict what your eyes might be seeing next, and based on the prediction, it will actually generate some signal. So that's like a generative model. So there's one signal that's coming from outside in through your eyes, and then there's other signal the brain is pushing down through the network, which is the anticipated signal. And so ideally, they will be same, but they may not be. So whatever the difference is, the brain uses that to learn and modify the network. So it's very much different from the simplistic CNN model for image processing, a lot more complex. For one thing, when brain generates that signal, it's based on some knowledge about the world, right? So for example, if you see some moving object, it know that your brain knows that it has seen that object, and then let's say it kind of knows, in next 10 seconds, what the object might look like. So based on that, it will kind of make a prediction and generate the signal, which is a lot more sophisticated than what happens in CNN deep learning models. So let's see what's next. So these are some articles that you might be interested in. I mean, I focused on articles that are easy to read. These are not really academic papers, but if you go into these articles, there will be reference to the actual paper, which will have a lot more, technical content, a lot more details about all these solutions. So you can follow up, and if you're interested, you can, read up on those too. But these are all articles and blogs, essentially, that I have. Is there anything else? Is that the last slide?
Yeah, I think this is the last slide.
Okay. All right, I'll end there, and thanks everyone for joining. Hopefully it was useful. Like I said, you can connect with me on LinkedIn. You can contact me also if you have any questions. So feel free. All right.
Pranab, maybe,
Thank you so much, Pranab.
Yeah.
I was just saying,
sure.
if people are available, meaning if they have any questions, maybe they can you can answer them now.
Yeah, sure.
Okay. So, hello everyone. The ground is open. If you have any questions, please feel free to ask us.
If anyone have questions, please raise your hand. Then you can unmute yourself.
There is a question to get Pranab's LinkedIn profile.
What is that? What's the question?
They are looking for your LinkedIn profile.
Oh, just search by my name. Just
Yeah.
search by my name. That should be enough. By my full name. I think I got some. I see on my phone. There are a few invitations already. Well, if that's the only question, then we are doing well. That means.
I just pasted in the chat some of your references.
What about the references?
The one that you had in your last slide,
Yes.
I have just given to the participants.
Okay. Oh, I mean those 5 or 6 URLs that I have.
Yeah, exactly.
Okay.
Aditi, you are getting any question from any participants?
Not yet, sir.
Okay.
So if they have questions, then they will ask in the chat box. You can continue
Okay.
then.
All right. All right. So should we move on to the next speaker, or should we wait for some time?
Thank you so much, Pranab. Really, really appreciate this.
Sure.
So we get
Okay.
some questions.
Oh,
What about forgery detection in image?
sorry. What's the question?
What about forgery detection in image?
I didn't follow that. Oh, for fraud detection?
Forgery
No.
detection.
Forgery detection. You mean for images?
Yes, sir.
If someone has forged some image, I mean that's a tough one. I mean, for example, this generated images, most people cannot tell the difference. They look so realistic, and actually, that's an active area of research. So there's a lot of fraud potential for a lot of fraud with all these generated images or videos, right? So that's an active area of research, how to detect that. I mean, the only way to detect anything unusual is doing some kind of anomaly detection. But as far as detecting whether some content was generated by a generative model or not, whether that's real or fake, that's an active area of research, and I don't think there's any very good solution for that yet. But I know there are people working on it. So they have basically created a monster by having this generative models because it's being abused a lot. Yeah, that's all I have to say.
Okay, sir. Thank you.
Forgery.
And
Sure.
so another query we get, to detect the plate of the vehicle number plate. So which type of AI algorithm should we use, or which will be good for the image processing?
To decide which one is bigger?
To detect the number plate of the vehicles.
I didn't follow that.
Okay, I will explain you. So the question is, Pranav, to detect vehicle numbers plate.
Okay.
To detect vehicles number plate, which type of AI algorithm for image processing is good?
Yeah, that will be that's something very similar to what Third Eye has done for ACE. So that will be basically RCNN. So you can think of each character in the license plate as an object. So you want to detect multiple such objects, right? So let's say the license plate has 6 characters. So it will detect 6 objects, each one within its own bounding box. So that's the second kind of vision task I had in my slide. Multiple object detection with RCNN network.
RCNN is the way.
Yeah, and obviously you have to train the model before you use it. I mean, you have to, I mean, you can take some pre-trained model, but you have to do your own additional training before you can actually use it for prediction.
That's great. Thank you so much. Any other questions, Aditi?
Shobhanant, I made you the panelist. I think you want to interact. So he made any project, so he want to interact with you. So you can unmute yourself.
Good afternoon, sir. Can you hear me? Good afternoon, sir. So,
Good afternoon.
my BTech project is basically adversarial effects against image forgery detection. Right. So, is there any resources? So, is there any resources where I can read up more? Like, there are very less articles that I'm finding. So,
If you can send me an email with some details of what exactly your goal is,
okay, sir. Okay,
I can try to help. I can try to help you.
So, I message you in LinkedIn.
Or you can message me in LinkedIn. That's fine too.
So, okay, sir. Thank you. Thank you, sir.
Yeah. Yeah.
I think that's all the questions we have. Nothing else, right, Aditi?
Yes, sir. Yes, sir.
Okay. All right.
Thank you so much.
Okay.
Thank you for everything.
Sure.
And it was just great hearing you. Thank you so much.
Sure. Hopefully it was interesting and helpful. And
Yeah,
thanks
it's
for
very
joining.
interesting. Thank you,
Okay.
sir.
And it's a wide open field. It's changing every day. So it's very difficult to keep up with. This is just a vision. I mean, there's so many different areas like text, image, language, audio, video.
Yeah, it's really helpful in getting the basic insights.
Sure. Okay. All right. Thank you again. So let's move on to the next speaker.
Yes. So it's my honor to welcome Mr. Vishal Yadav. He is our full stack lead as the next speaker. Welcome, Vishal.
Yeah, thanks, Prashanjit. Hi, everyone. Good morning. So let me share the screen. Okay, so I hope everyone can see the screen now.
Yes, it's clearly visible.
Okay. So basically, I'm going to talk about various Third Eye projects. So in recent time, like Third Eye has done like a lot of projects. So I have just selected the lucky one. So I'm going to explain 2 to 3 projects down the line in this session. So we'll start with the famous question like, can AI replace something or not? Okay, let me just switch off this notification. Okay. So this is the famous question, like generally, like in every session or in every discussion, the thing like, can AI replace or not? So the thing is like, I found a line like to answer all the discussion regarding this question is like, neither human and nor machine can replace its creator. So this is what I find the ultimate answer for this kind of question. So it can progress a bit, but it will not like fully 100% replace anything, because the way it was designed and the way it was constructed, it's not going to happen like in anything in any time future as well. So the agenda will be, I'm going to introduce myself and we are going to walk through 3 model. The first one is anomaly detection, second one is semantic search engine, and the third one is chatbot. And at the end of this, I'll try to show a small demo if it works. If it doesn't, then we'll see. So who am I? So I have started my career as a data engineering, and I have done like a lot of project on that. And at the same time, parallelly, I have also done project on data science. And the fact is, I have being a data engineer from last 4 to 5 years, I have done more project in data science compared to data engineer. So I'm kind of like designation is data engineer, but I'm kind of like filling the gap between this two in. I'm trying to connect this two in. And it's also very important, like being a data science, you should know what is the data engineering component, or being a data engineer, you should know what is data science, and then you can develop such application that can work end to end. So in a funny way, what I say is like, I'm married to data engineer, but I'm in love with data science. So this is who I am. So let's talk about the first model about anomaly detection. So what is anomaly detection, we'll try to understand, and let's time travel to understand what is anomaly detection. So if you remember in your class, maybe 2-3 standard, we try to find out what is the odd one out among various picture. So in childhood, we call as odd one out when we go like pursue some career. The same concept goes to anomaly detection, but it is the same of odd one out. So in this picture, if you the first category, if you see the odd one out is the last one. In the second category, it is the second one and followed by other one. So you can see the right hand side, the answer of it. So basically, this is the odd one out. So whenever if there is an unusual behavior among the data set, you are going to say this is the anomaly. This is not the usual behavior of the data set. So if you notice, like we are not finding the usual or unusual behavior throughout this picture, we are categorizing, we are saying like at category 1, what is the odd one out? In category 2, what is the odd one out? So here it comes the second part, the complex part. You have to find out anomaly detection, but in a cycle, in a season. So here it's saying in a category wise, but in our terms of anomaly detection, we generally say in cycle, in trend, or in some seasonal. So I'll give an example and then I'll move forward to the next slide. Let's say like the way you buy something. So basically in India, like we generally prefer buying something in Diwali because also we got sales, we got some discount over Amazon or Flipkart. So if you see your like the way you bought something, it will like over the year it will like maybe 1,000, 2,000 or maybe 500, but suddenly in Diwali it reaches 20,000 or 15,000 if you bought some phone. So it's not an unusual behavior if you see the cycle, if you see over the year. So it will see like January, February, maybe 1,500, then suddenly in October, November, it goes to 10,000 or 20,000. So you can say this is anomaly looking at, there is a peak in Diwali, but it is a usual behavior. If you look at 5 years of data of yourself for buying something. So this is all about anomaly detection, and this is the cycle, the season. So it's not only about odd one out, it's about odd one out, keeping in mind various conditions. That condition be cycle. Cycle means over the past year or over a season, how the data is going up. If the data is going up in every October, then mean it's a normal behavior, not an unusual behavior. So what we did in our project is, so we got some data. So this is the data that if you are using Linux system, you can just type a command top, you will get this kind of data. So generally showcase how your CPU and how like everything consuming the memory. So the client, the data that we got from client, they have running various virtual machine, or you can say various desktop machine. And based on that, the desktop or the virtual machine generating some CPU or memory data. And we have to find out whether any system is like taking more memory. If any system is taking 90 or 100% of CPU, it means the system is in danger. We have to inform the end user to say like, okay, this system is continuously running at 90% CPU. Either you provide some extra hardware or you just need to shut it down because it might create some problem in the production. So this is how the data set, and this is how the requirement of that. So it's to sum up everything. So we got the data. So you have to find out at what condition or at what time the system can be create some problem. So before the system reaches 100% or crashed, you have to find out this system can crash, and you have to notify. And how you are going to notify, you can say like, this is the anomaly behavior of a system. This system never crosses 60% of CPU, but now something is happening and it reaches 90 to 95%. So this is, you have to inform that. So this is the data set. You can take any data set, but this is the generic data set that we got. So this is the overall execution flow. So we got this customer data. So there can be here, customer means not various customer. It can be various customer, but you can treat comparing to the previous diagram, previous data set. You can see like there could be various machines. So each machine you can say a customer. There could be a various n number of customer. Then you are going to write some algorithm. So the concept of this one, we are not going to write just one algorithm of anomaly detection. We'll try to write more than 2 or 3 algorithms, and at runtime, the best algorithm got selected on top of that data set. So in generic way, what we do is like we take data set, we build an algorithm, and then we predict. But in this way, what we have done, we are saying, what if that algorithm fail for that data set? We have to be, we have to prepare for the worst case. If the first model is not performing, then how about the second model? So on the same data set, let's say this is the data set. So we are running 3 to 4 model on the same data set, and we are trying to see which model is performing better on that instance. And based on that, the model will be selected at runtime and followed by the prediction. So the middleware is the various algorithm that is trained on the same data set and is going to predict on the same data set.
Vishal,
Yeah.
sorry to interrupt, but people are saying please speak slow.
Okay.
They're unable to follow.
Okay, sure. Okay, so I'm going a bit slow. Okay, so we have various data sets. So based on that, we need to design various algorithm, and based on that, the best algorithm will be selected on that data set. And based on that, the prediction will happen. And so this is the middle. So I think the left component is clear. You have the source data set. Source data set can be anything. In the middle, you have various algorithm. We'll talk about the algorithm, but the thing is, in the middle section, you have various algorithm, and the best algorithm will be selected at runtime. So the prediction will happen for all the algorithm, and the best can go to the end user. And there are various other components. If you see Apache Spark, then the notebook, and then analytics dashboard. So why we are talking about Spark here? So basically, when you have a lot of data set and you want to predict maybe on terabytes of data and you want to process that thing, so it's not only about the model building and like predicting everything, because if you build the model on maybe 1 KB of data or maybe 1,000 row, it will perform the training as well as the prediction. But once you reaches maybe millions of row or millions of file, the whole system is going to crash out. So to handle that kind of load, we have to need some framework that can balance it out in terms of processing, in terms of storing that capacity. So here we are not talking about storing, we are talking about processing. So we generally use Apache Spark. So Apache Spark basically in a short way, I'll say it's a runtime mechanism where it will perform all the processing in RAM. And so whenever anything process in RAM, it's obviously like it's quite good compared to if anything is processing within disk. So Spark help us out to process, and also Spark provide various ML library that you can use to as well as model build and predict. But here we are just using Apache Spark to process the output data as well as the input data. Then the notebook. So notebook is just to run everything. So we have developed the model within the notebook. So notebook is a good thing if you are developing anything related to machine learning. The final one is the analytics dashboard. So once your prediction is ready, so you can just publish the data in any kind of dashboard. The important one is about the feedback loop. So let's say you are saying like maybe taking this example, the first row 0.6 CPU. So you are saying this is an anomaly. And the user, after prediction, the user said, no, it's not an anomaly, it's a usual behavior. So the second task is how you are going to feed that prediction or feed the result back to the input layer, back to your model training process to say like, okay, you have done some mistake, you are going to correct that thing. So this is how the feedback loop work. Based on the prediction, we are going to add that data set, and at the time of the second iteration, we will say like, okay, see, 0.6 is not an anomaly, it's a normal behavior of the data set. So the next time the model will run, it will try to fix its mistake and try to say it's not an anomaly and it's a usual behavior. So let's quickly go to the execution methodology. So that was the architecture, the flow, and it can be like in other as well, but this is how we have done that. So step one, basically the data ingestion. So whatever the data is there, you have to collect the data set. So in data engineering, we generally say ETL, extraction, transformation, and loading. So depending upon where is the source of the data set, you have to extract. Then if the data set is not clean, you are going to transform or then load the data set somewhere for your model building and then prediction. So data ingestion can say like it's a ETL, then algorithm selection. So at the first time, whenever you try to build something, it's not like you just Google something and you will just pick an algorithm and say like, okay, I'm going to apply this algorithm on this data set. Generally, as a data scientist or as a developer, you have to try various other approach, and based on the evaluation and the accuracy score of the model, you are going to select one algorithm out of maybe 6 or 7. Then the model development, so you have to write that code. Then comes like all the graph and chart. Based on that, you can say, okay, this is the perfect model. And the fourth step, you are going to deploy that model in the production. So in between models, algorithm selection and model development, the model training and retraining will be various iteration. It's not like on the first go you will select the algorithm, it will perfect fine. You have to keep retraining, introduce some new data set, and based on that it will improve eventually, not at the first time. If you are running a model and at the first time it's saying like 90%, so there are two things that can happen. The first is you are doing some git clone, and that's why you are getting 90%, or you are just like your something is went wrong, because at the first time if you are getting 90 or 95%, something is bad happened. So in joke we say like at first attempt if your code is running, then something is wrong, rather than after 5 or 6 attempts your code is running, then it's fine. So jokes apart, so we'll talk about the FB Prophet model. So it's developed by Facebook by its core data science team. So FB Prophet, the way algorithm work is basically on the seasonality, and it track the multiple period over the time, and depending upon that, it try to find what could be the anomaly based on the seasonal, based on the cycle of the data set. And it's also like it's basically for the time series data set. So time series means the data set will be you can compare as a key value. Key is a timestamp, and the value is at what time the value is this one. So if you remember the data set, so I'll say like today is maybe 10/4/2020 at 12:26 p.m. The CPU is 0.6%. Then maybe after 1 second or after 1 minute, I'll say the memory is this much. So that was the time series, and based on that, FB Prophet can find its cycle, and based on that, it try to find where is the peak, where is the anomaly of that data set. So this is the first model that we have developed, and based on that, we have another model that is my favorite among other models. So it's say like LSTM. It sound as long short-term memory. So I don't know like how much you are familiar with this movie. So this was the movie, I think late 28 or 20, maybe I think after 3 Idiots this was released. So maybe 2011 or 2012. So the movie name was Ghazni. So the character is kind of after every maybe 1 day or 2 day forgot what he remembered. So he usually try to write on his body or make some note. So in the movie, they call it a short-term memory loss. So in the same way, the algorithm LSTM long short-term memory, it work as it tried to remember the previous data set, and based on that, it tried to predict the next one. So it tried to learn what is the data set 1 week back or 1 day back, and based on that previous data set, it's going to say what could be the next data set. If the next data set is same as the previous one, then it say okay, everything is fine now. If it not, then it say like it's not the usual behavior of the data set, it may be an anomaly. So in the graph, if you see like the orange one, till the point it reaches 5, it's saying like it can be a normal data set, but once the data set is above 5, it's saying no, not now it's not a normal. The previous data set is not beyond 5, it's less than 5, so it might be an anomaly. So the way it works is the probability of the next word depend on the previous word in the same context. That is very important. The context should be same, and the train language model can predict on the next word given a set of previous word. So it train on that data set, and the prediction will also happen on the same way the way we have trained the model. So this is LSTM. So we have talked about model, we have talked about the architect, and how you are going to design that thing. So if you remember, like we already said, like in Indian parent, they will say like once a wise man said, and I think everyone say that. So once a wise man said, like behind every great man, there's a great woman, and this is all over the world. Now the time has changed. The same old man is saying, behind every great model, there's a great data. That is a very important line. So it's not all about the model, the algorithm. So I'll say like it's it's also about 60% of the data, because data is the key and everything depends upon the data. If your data is garbage, so the garbage in, the garbage out, this is the term that the people use. So it's, if you use the high quality model, like the best model in 2022 running on that maybe the best computer, but if your data set is garbage, you are not going to predict anything. So to do any project on data science or machine learning or AI or whatever it is, you have to make sure the data set is something that you can work on that. If it's not something, make it something. Clean the data set, prepare the data set the way model require. So there's a dialogue. So I'll modify the dialogue. The dialogue say like in a movie, in the Hindi movie, but I'll just remodify the dialogue. Say that मॉडल को तो लोग यूं ही बदनाम करते हैं, असली तकलीफ तो डेटा देता है. So if you have already worked on that, you know what's the essence of this line. But if not, then you will realize like it's not about the model. You will get the model from anywhere on the internet, but you will not get the data. If you get the data, you will suffer with the data. That is means as a data scientist, you will spend your 60 to 70% of the time on the data rather than the model. Till you didn't reach or you have not developed anything, you will see like algorithm, but you will see once you develop something, you will understand it's data plus algorithm. So this is the first project, and I'll go to the second project that we have done. It's semantic search engine, and we have done like for various client, and ultimately after doing that for various client on various cloud platform, then we have like developed the same application in-house without using any cloud services. So it's basically based on open source, and the idea was very like very simple. And so let's understand like what is semantic search. Search is basically a Google search, you can say, but the meaning of semantic search. So if you have like seen this movie PK, there is a scene like he explained like in India or in any, basically in India in Hindi, the acha word can be mean anything depending upon the expression of the person. And Amir Khan like clearly explain that behavior. Like if you say acha, it can be a good, it can be a bad, it can be a neutral. So we say like bhavnaon ko samjho, that is I mean. It doesn't say like if someone say, if you say a bad news and someone say acha, it doesn't mean that he said like okay acha hua jo hua. It means okay acha. So it kind of expressing a sympathy as well for a bad news. So the term, the very important term is bhavna. You have to understand the essence of the word, not the exact word. So let's take an example to understand this concept. So if someone say let's run Python program, so assume a person who do not know programming and you are saying to him let's run Python program. What he try to say, he try to visualize this picture and he say okay, I have to run this Python and we have to create a program for running this Python. But actually what I'm trying to say, we have to run a Python program on this, not the left hand side. So the problem is whenever you try to search something, you have to understand the essence of search rather than direct search. So let's say the HR is searching something called 5 years experience of Python program. So it try to search on this Python programming language rather than experiencing on this Python programming language. It's not a programming language, but this Python snake. So you have to understand that. So this is how semantic search help. It try to understand the essence of the user and try to fetch the document, and based on that it serve the user. So it if I say like semantic search is same as Google search, but Google search work on worldwide data, but semantic search engine is working on your own data set. So let's say like in your local file system, you have thousands file, PDF file, doc file, any kind of file. And now you want to perform the way you do Google search. Let's say you have maybe a log file and you wanted to find like why this, what kind of log is this, when this log occur or when this error occurs. So on your local system, you have to fetch the document and try to get the top 10 document the way Google says. So semantic search engine is the same search engine, but on your local doc. And we have this is our in-house project. So it work on algorithm that call as topic modeling. So the backbone of this one is topic modeling. So say like we have various document on the left hand side, and so this is in the middle you have that single document. So we try to run various algorithm on the content part of the document and try to build various topic, try to find out the key phrases, the important word, the topic, or any word that can we can store in our database. So once we have done that, running the algorithm on top of each document, we try to categorize the document in various format and try to score the document based on the user query, based on the content, and based on how the document is described itself. So there are various things that is linked with that. But to summarize this one, you read the document, you build the index of that document, and based on that, when the user searches something, you are going to fetch the document, the best relevant document for that user. Here the important word is relevant. So relevant means you have to understand that bhavna, you have to understand the essence of the user. So when user is searching for Python, you have to understand the domain of the user and then get the required document of that. So search enrichment is a process for achieving semantic search from a keyword search. So there are two terms if you are familiar with the search engine. If not, then I'll clearly go with that. As a simple explanation, keyword search is something like, let's say I'm searching this the same slide, and in somewhere if I search, let's say search enrichment. So search enrichment is physically present in the document. It will go and match. So if you say like in SQL query, if you say where employee salary is something, or where employee address is something, you will get the exact match and you will fetch the document. But what if the same word is not present, but maybe you can relate the synonyms word, or that essence of the word is present in the document, but exactly not the word that you are searching is present in the document? Then the semantic search come into the picture. You have to understand the essence, you have to understand the bhavana of the user, and then get the document. And followed by we are running like various machine learning model on top of topic modeling and what to where to categorize and to serve this semantic search. So it's not going to it's not a magic that semantic search will work on any kind of document. You have to build that logic. So to build that semantic search, we have to run topic modeling on the content of the document, and then we have to categorize the document so it can find the essence, it can find that reference document if not the actual keyword is present. Along with that, there are other features like key phrase extraction. So key phrase is basically the important word. So key phrase could be like here, if I say what is the key phrase, so key phrase is machine learning. So this is the key phrase, not the word. So key phrase is when more than one word is aligned with that a single word, or you can say a phrase of that word. It can't be like just one word. So that was the key phrase. So we try to find the important word, not just the word, combined sentence, you can say phrases, and then store in the index so it can help when the user searches something. Additionally, we'll provide we are tagging a document with additional synonyms. So here synonyms is not like for every word of the document we are going to add that synonyms, because it will, the corpus will be huge. So you have to find first the important word from the document, then add those additional synonyms, or you can say tag the document with additional word. So to sum up everything, we have a document corpus. The corpus means the content of the document. You have to extract important word, and then for each important word, try to add more important words so it can eventually enrich the document with more word. Eventually, when the user searches, it will get the document. So what we have machine learning model in here, where we have trained the model, and then at the prediction we are doing that. Also there are other features like text summarization. So the document could be thousands lines of content is there in the document, so you have to summarize that content, because if you see in Google search, if the page is maybe 100 pages long, you will not see that 100 pages content on the top search. So you have to, in Google search, you generally get 2 to 3 important line reference to your query search, and that you will see in the search page, means the important word. If you see what is Python programming in the search, you will get Python programming is dash dash dash, the 2 lines. So that we achieve using text summarization, then document categorization, and finding meaningful insights. So let's go to the dashboard. So before that, why would you someone use SSE? SSE is just the short form, semantic search engine. So if you remember, I was talking about the local document where you can search. So document can be anything. So this application can serve like the PDF, scan document, various kind of doc, CSV file, text file, any kind of mail attachment, or any image file as well. And based on that, it try to fetch the content, index in our database, and then all the model can enrich the document. So this is how the look and feel of the pages of that one. And this is also one important feature of this is called a hierarchical search ability. So where, let's say if someone is searches like this is the search term like P033999. So the document is basically for a particular domain where it has some information about pipe or some other domain. So what it does for this search, it say like this is your exact match for this document. Now it try to go like beyond this one, means first the first label, and then it say like, okay, for this pipe you have this customer. For this customer, you have this invoice. For this invoice, this is the document. So if you see, like, for the first label, it's not we are saying like this is the exact match or this is the search that you are getting. We are saying like this is the relevant document for yourself for the query. But for this one, these are the various customer. So this is very domain specific, but it can be very important if you integrate in various hierarchical ways. So the user can get all the data in a similar fashion. So if you have company information, then you can say, okay, for this company, these are the top search for the company, then these are the employee of that company, then these are the resume of this company, and you will get this information at the right hand. So this is the hierarchical that you can build if you have that index the way we have just explained. Another one is it's under Cloudity. So Cloudity is the part of Third Eye, where like Third Eye is basically a service company that we provide and build various services or application for customer. Cloudity is a part where we develop our own product, and based on that we try to maintain that product. So there are various product that Cloudity offer. So we can say Third Eye offer, but it's under Cloudity. So this search engine is a part of Cloudity as well. So this is how the user searches. So user searches machine learning. So this is the first document that got, and followed by others. So if you see, like, these are the top, the way Google work will try to replicate it. Like, it's nowhere near to that one. I'm just referring to get a better understanding. So these are the like resume that we are getting for this word, and then the highlight of that resume, and then the important word. So assume like HR has millions of resume, and he or she want 5 years of experience in machine learning. You simply search in their search engine, and they will get the top CV, and they don't need to look the full CV. They can just go to the top word keyword or just the summary of the resume, and then based on that the resume can be selected. So it's an application for that as well. So it's not generic to a particular domain. It can be very vast in various domain, depending upon how you have integrated or developed this thing. So the benefit is time saving, obviously, because as I was talking about the resume, you don't need to go 1,000 resume. You just need to search and you will get that. The search speed is quite fast. The database is quite fast, the way we have built that. And also there's one feature that is answer your question. So we have ran a seminar on that one as well, where we try to index a document related to Mahatma Gandhi, all the freedom fighter, not just Mahatma Gandhi, and where we ask question, not the search question. Where we ask is why Nathuram killed Mahatma Gandhi. So this is not about I need some document related to Nathuram or Mahatma Gandhi. I need the answer why. So that kind of answer the search engine can also give. So you have to run some other model. So if time permit, we'll talk about, but this is there are some model using word embedding on TensorFlow where you can get the specific answer for a specific question. So the third project that is related to the NLP field is Syra chatbot. So Syra is for Third Eye, where we have that chatbot, and it's very fascinating the way we have developed that. So let's understand like the backbone of any chatbot, or understand like how the chatbot works. So the backbone of the chatbot in a two-word is intent and entity. Intent is basically, if you see, if there is a question, and I think everyone is familiar with the way chatbot works. So let's say you are asking something is, I want to book a flight from Delhi to New York on 11th of August. So the intent is book a flight. Intent means what you want to do. So I want to book a flight. Entity is like book a flight, but where? That where is going to answer in the entity section. It's saying Delhi, New York, 11th August. So all the important word is going to answer by the entity. So once you find this intent and entity in any sentence, you can design any kind of chatbot. So the way this chatbot work is, the user, let's say, ask what is the balance of my checking account. So first it will try to find the intent recognition. So intent can be anything. So here intent is like get balance, because the user is asking for account balance. So the intent is get balance. There can be any intent like find location or pay bill. So the second step is find the intent. Based on the intent, find the entity that is present in the question. So the entity is account name. So by combining these two information, you can answer, or you can train the model based on that. So for every question in the chatbot, you have to train the sentences based on the entity and intent. Let's say if you say in the training part, you will say if there is an intent of get balance, and if the entity is account, then return or query on this database on this table. So this is the flow of any kind of chatbot. And also like in Saira also we follow the same kind of concept. So what is the objective of Saira? So the whole idea of chatbot is to engage customer with a more human-like interaction to achieve goal and meet ROI. And it's, I think, for all the big organization and all the service sector, I think they are moving towards, I think 90 or 95% is already added or integrated chatbot. But I think based on some Google search, what I found is 95% of the business will use chatbot till 2025. And it's not to answer everything, it's just to serve the customer in a better way without delaying anything. So the chatbot, what is the chatbot? Saira chatbot is basically can do. So if you are familiar with the Shopify is a platform where you can sell anything and you can open your store as well. So the Saira is not just for Shopify, it's for various domains. So I'm just going to explain how the chatbot can help in Shopify as well. So basically, let's say you have opened a store in Shopify and you wanted to use this chatbot. So what chatbot can guide you is, it can, so the ultimate answer is you will earn more money by using any kind of business logic, or I'll say like with use of chatbot help you can increase your business. But how? So based on the data set, based on the user that are coming on Shopify, the chatbot is not just the question answer, there are various other things. So chatbot is basically the user interface where you can interact with the user, but at the back end, you can develop various other things. Like let's say on Shopify, you are tracking various user, how the user is searching on a Shopify for a product, whether it's clicking on that product or not, and based on that, how the recommendation is happening, all the flow. Like if you're not familiar, then Shopify, then just visualize the Amazon or Flipkart. You search something phone, then phone by, maybe you go with cover, then you do not buy, then you go back, then after 2 days again you go and search. So these are all the data, the important data, how the behavior of the user. So all this thing can be logged in the backend, and you can run something. It may be algorithm, it may be just the if else, and based on that you can inform chatbot, okay, if this user is interacting with you, try to show this product, try to push that user on that direction. So that can be managed using this chatbot. So it's not just you can take help of chatbot just to interact. You can do various other stuff with the help of chatbot. So what it can do, to summarize, it can analyze your customer. It can say how many session, means number of store visit for a particular customer, unique visitor. It can answer most common question, most common intent. So these are all the backend data that we can gather, and based on that we can train the chatbot. Because the chatbot is not just like hello and then after some question the chatbot will say sorry, unable to understand. So there are more thing, and that more thing is basically the way you can gather the data and the way you can train the model on top of that. So as I talk about, like, it's not just Shopify chatbot, there are various chatbot. So the way we have designed is like we have categorized the chatbot for various domain, for various industries. So we talk about Shopify chatbot, there are retail chatbot, immigration chatbot, legal chatbot, travel, human intervention chatbot, and many more. So there are various domain, and all the domain can't be answered by just one chatbot. There should be a specific data set for that chatbot, so the chatbot can serve that specific target customer. So these are various chatbot, and it's the list is not ending here. It's just the showcase, and in any domain the chatbot can integrate it. So let's go to a sample demo chatbot. So this is just for like information. This is not the Saira chatbot. So in morning I have just like added one chatbot just to showcase. Chatbot is not about hello and how are you and then good morning and followed by some just the if else kind of a statement. There are other essence that are talking about. I love this word bhavnao ko samjho. So chatbot, if your chatbot is understanding your bhavna, then it means it's working fine. So what I'm trying to say, let's go to a demo here. So I hope it's visible. Yeah. So this is a chatbot for that one. Just a normal conversation. So I'm going to give you a context of this conversation. In India, basically, when two friends wanted to meet, they try to fix a time, and based on that, they try to we'll see like how the way the communication go on. So chatbot is two friend is there, and one is chatbot, one is real friend. So I'm acting as a real friend, and there is a chatbot that I don't know. So how a chatbot can understand the intent or clone my other friend and the way it react. So we have said like, okay, good morning. Till this part, the normal chatbot is okay. I'll say hello. This blue one is my friend or a chatbot that I don't know. It's saying, okay, hello, how can I help you? Then I'm saying good morning, then hello, good morning. It's okay. So this is normal chatbot. Now comes the part where we use this kind of language. 90%, I think, we hardly use the proper English within our friend circle or within, like, professionally we use that proper English, but now it's kind of English, will say, where we pronounce Hindi but write in it English. So I'll say like बहुत दिन हो गया, आज 4 बजे मिलते हैं. The friend say okay, ठीक है, done. So after then I'll say like maybe भाई 4 बज गया. So generally like when the 4 बज गया, I'll say 4 बज गया भाई किधर है. I hope it will return. Okay, let me refresh. If it worked, then fine. Otherwise, I'll try to explain what I'm trying to say. Okay, let me start by char. Okay, let me say just good morning then. Okay, now it's working. Okay. So, भाई 4 बज गया. इधर है. Okay, so this is the usual response that I generally get, like 5 minute bro. Okay, after 5 minutes, let's say 5 minutes is done. So I'll say like भाई 5 minute हो गया, किधर है? 5 मिनट बस ट्रैफिक में फंस गया हूँ. Then it's okay. I'll again like wait for 5 minutes. Then like with some गुस्सा I'll say like किधर है, with a short sentence. Again the same reply. 5 मिनट बस आ ही गया हूँ. Then after an hour I'll say like भाई 1 घंटा हो गया, तक किधर है? And the same response, it will go like on and on. आ गया बस. So the main intention of this one to showcase is like, in any NLP field, we have to move forward to the next level where we can understand this kind of sentence and try to answer this kind of question. So it's not just about hello and whether you want to buy something. You have to understand the essence. And maybe I think moving forward, we have to understand this kind of, or treat this kind of language as well, because the user base for this kind of language is more compared to the user base of a proper English with a professional language, I'll say. So moving forward, I think the chatbot will go in this direction. And I remember like from Zomato, some notification came and it will say like आज कुछ order नहीं करोगे, means Zomato is asking me in my own language. So I'll connect with that customer like more compared to if someone say, do you want to order? If someone say, buy order kuch kar lo. So I think Zomato is using, but it's hard to train on this because this kind of language is very regional. So in Kolkata, we generally say this, maybe in UP or in Delhi, this kind of language. But if you go to the lower part of India, maybe in Bangalore and somewhere, maybe this language differ a bit. But this is the way you have to think about this kind of language or support this kind of language as well. So this is the way we have to think about. Okay, so let me just wrap up very quickly where we have left. Okay, I think this one. Okay. So we have seen like a chatbot is not just the direct match. You have to go to the next level to understand the regional language, the regional sentence, and then integrate to that one. So it again, like in the backbone, it's still like intent and entity. You have to understand intent and entity in that language. So 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 this is kind of a very common thing is like if you remember like everyone like in engineering field, whatever the like I'll say what stream is there, if it's computer science, obviously like 99.99% or maybe 100% student is going for AI, data science or machine learning without knowing what it is. They just want to pursue that career, and it's also a good, but you have to know like it's not just AI. So ultimately, like in our industry also, like whatever the problem is, like we generally close the eyes and say machine learning can solve or artificial intelligence can solve, and the client is also happy. And so in some cases, client is also saying like, this is my problem and you have to solve this problem, but with AI. Means give us a chance to understand the data set. Maybe just SQL query can give you the satisfaction or give you the result, but the client is no, use AI. I don't matter what you use, but it should be algorithm. So it also helped their customer to sell because AI is a buzzword. So can we say like this is the new god where it can solve anything? So I don't much know like how much you are familiar with this man. So this is a famous man. He treat everything, and after certain time he'd say like kabhi kabhi lagta hai apuni bhagwan hai, because he can do anything whatever he want. So before 3 to 4 years he was the god, but now we can say can machine learning can say like kabhi kabhi lagta hai apuni bhagwan hai, because machine learning, AI, BL, whatever you can say, it seems it's solving all the problem, but the reason is not, but the buzzword or the the news that is in industry or in the college is like machine learning is everything, AI is everything, and everything is going around this one. So the buzzword is just the part of a big picture. What I understand, it's not like I have read something, but based on my experience, what I understand is just just the small thing in a big picture. So it's not just about AI, it's about the how architecture design the system. So there are various other domain, various other role that people play to design an application. So it's not just about AI, it's about how an architect is designing the system, because that is important. Then it's about how the DevOps set up all the infra and pipeline. So if I don't know like how much you are familiar with this domain, DevOps, it's very promising. And if you are going with machine learning and AI just for salary, then I'll say like go with DevOps. It's very demanding, and in some cases it's the package is high compared to AI, data science, or DL. So it's also about if you are designing a system, it's also about how the DevOps set up all the infra and pipeline. It's also about how the data engineer, the backend developer develop the system and prepare the data set. Then the AI engineer on the model building as well. This is our favorite part. So everyone just stick with this point. But it's also about various other area like the UI development, because you can develop the model in your notebook, then no one can use. The UI should serve that your model and then publish somewhere. Scrum master, project manager, tester, various other roles and responsibility is there. So the conclusion is it's good to pursue a career in AI engineer, but I'll say like at the starting of your career, try to learn various domain, because it help you. If you become an AI engineer or machine learning engineer or any engineer, then you will get a full picture, and it just not you will be a blindfolded, or by developing some algorithm you will understand like end to end if you understand all the domain. So I'll say like before choosing any career or choosing any path, try to go with all the flow, then based on your interest pick anything. There is no like I'll say like there is no small or big career or a small or big domain. If you are best in anything, you are best. If you are best tester, then you are best at that thing. So this is all based on my thing. So yeah. Okay, so this one is also okay. I have just one thing, maybe I can share. Okay, just one line. My line is favorite. Okay, this one. So the final note that I forgot to add it in that slide, but I'll just try to read. So this line is say like from I think Raj Kapoor in late 1950 or 60. So I just modified that line. So I think everyone is engineer here, or maybe become engineer after some years. So the line say एक दिन बिक जाएगा माटी के मोल, जग में रह जाएंगे प्यारे तेरे कोड, दूजे के हाथों में देकर अपना गिट, here is a GitHub, कोई निशानी छोड़ फिर दुनिया से डोल, एक दिन बिक जाएगा माटी के मोल. So keep learning, keep coding, and left something that the other generation can learn and progress on that. So I'll say thank you and keep in touch, and best of luck everyone. Hope somewhere sometime we'll meet again.
Brilliant, Vishal. Excellent.
Yeah, thanks everyone.
So much,
Very
Vishal. That was
exciting.
very
Very
good.
exciting.
Yeah, thanks TJ.
Did you want to say something? Okay, so I think it was very useful for all of you. And we have actually prepared the workshop today in 2 sections. First 2 hours we have finished, and we have another 2 hours to come, but we need to take a break as per our agenda. Aditi, we will take a half an hour break, 30 minutes break. And
Okay, sure, sir.
participants, please come back, because we have a lot more exciting informations, update, and technology to share with you. And we are just taking a call. 1:30 sharp, we'll come back. And what is there on the other side? More exciting. I'll just give you a hint of that. How you can use data to prepare your models, right? The entire process, collection of data, preparing the data, building the models, training the models, and implementing in real production. So much of exciting, right? All those things are coming up post lunch, and we'll have Neha and Ipshita. We'll go over that. After that, there will be a QA, completely open forum for you, where you will be asking questions and we will give answers. And in the end, I will be talking about the opportunities and the internships. Okay, so stay tuned. Have a very good lunch. Okay, regain your energy. Come back by 1:30, and we are keen and we are so much expecting to see you again. Thank you. 1:30 will come back. Aditi, you are there? She's not back yet. Okay. Let's check at 135 how many participants we get. Okay. 4 more minutes, please. we need to respect everybody's time. So 1:30.
Yes, so we can start now. I have circulated the messages also in the groups that the break is
Okay.
over.
All right. Okay. So just give, I want to just give 1 more minute. Just 1 more minute. All right. So thank you everybody for coming back. What we have covered pre-launch session, right? Our CEO, Mr. DJ Das, has talked about the organization Third Eye and what we do, what we deliver for the customers. After that, it was followed by the speech from our respected Chief Operating Officer, Madam Aparajita Das. She has explained you some of the deliverables that we have performed, some of the challenges that we have faced in various customer relationship, and how we actually dealt with those challenges and implemented the project successfully. After that, you got Mr. Pranab Ghosh, the Chief Data Scientist. We call him Pitama of deep learning, machine learning AI field. And he has talked about a lot of models, different generation of models, what are the different ways to use the models and the use cases. After that, Vishal has given an excellent presentation on the various practical projects where he worked on. And it was so exciting and really like the way he used the Bollywood movies, PK and Gajini and all that. And that really actually makes the session more fun feeling and exciting. So hope you enjoyed a lot. And I want to say my heartfelt thanks again to the Cognizance IIT Roorkee for their continuous support. And last but not the least, you, the participants, right? You make an event successful. Without the spectators, football, cricket, whatever you say, it's not make any event with a full fun feeling. It doesn't work. So you all have actually taken time out and participated today. So thank you so much for your time. Now, the next session we are going to start where Neha will come and she will be supported by Ipshita. They will be giving a brief introduction of themselves. And there will be a lot of insights that will be shared with you in the practical project where they have implemented some of the models. So basically, this solving real world industry problem with AI computer vision, you are going to see now. So that is very, very interesting session, which is coming up. And stay tuned. I'm giving the platform to Neha and Ipshita now. Thanks again.
Thank you, Prashanjit, for the intro. So let me share my screen. So first of all, to start with, this is Neha here, and I work as a data scientist in Third Eye. And today I'll be talking about one of the projects that is being mentioned by our CTO as well, where we have solved the computer vision problems. And I'll be showing a demo which will be a mimic of the same thing that we have done, but not with the real models and real data set. So I'll be showing that, and I'll also provide a walkthrough of one of the cloud platforms to show how exactly we start with the projects and we release it to the endpoints. So these are all my agendas where I'll be covering from the starting with what is AI ML and deep learning with till the real life deployments. So to start with, I would say whenever we are trying to mimic anything that humans can do is what AI is. So here we try to like the intention is to make things do like a human, like how human do. But yeah, we are nowhere very close to it. But yeah, the motivation is from the humans. And inside AI we see there are two parts, ML and deep learning. So these are the subsets of AI, and both of them like have some different specific areas where we deal with. But in and all, if we talk, then AI deep learning is a subset of ML, and ML is a subset of AI. So some of the practical applications that we can see in real life is the recommendation systems, which is like which takes customer feedbacks as an input and help to enhance the customer experiences. So it recommends like what can be the important products that customers will be interested into. So it can predict like that way. Chatbot, like the one chatbot that we have already built, Saira, and Vishal just showed a quick demo of it. So interactive communication with the real human. So this is what the chatbot is, and we can build it using AI. Self-driving cars. So these are also being we have started getting self-driving cars now. So that is AI. And for ML, uh, in ML, what we do is we create a system which can be trained to act. So the three main algorithm that we have in ML is supervised, unsupervised, and reinforcement learning. And in supervised learning, what happens is we provide the machine or any system complete input and outputs, and the system itself trains it and predicts the output for the new unseen data. So but initially we provide the system with the inputs as well as the outputs. But in some cases where we don't have the outputs with us, but we have huge lot of historical data, and there are some algorithm in machine learning which can be trained on that and predicts the output. So that is what unsupervised learning is. Reinforcement learning is again a very new thing in ML, and it is being widely used in applications like gaming and all. So right now we are like many of the video games are using reinforcement learning to train itself. And like what it does is reinforcement learning provides the rewards or the minus points whenever it sees any positive or negative things, and it train itself during the path of predictions and make changes and improve itself and performs. So many of the gamings are being used, they are using in reinforcement learning nowadays. To go on deep learning, uh, deep learning works with it works very well with unstructured data. When we don't have the tabular data and with images, with the text, so it can work with on any kind of data set, and without any human intervention it can prevent the outputs. So one of the application, computer vision, will be seen in our upcoming slides. So to before that, I would like to tell you like what exactly changes in AI ML than what we were doing earlier. So in traditional programming, as you are aware, there was a programmer who needs to write the code and predict send out the outputs. But the code was nothing but the rules, if else cases, or any like logics that we were known beforehand, like before writing the code. But what happens in AIML, we point our inputs to some algorithm, and it train itself, it learn from that rules, statistical models, and it predicts the output. So here we have completely, like earlier we were providing the input. Let's say this is one of the diagram is shown as per the one of application like spam detection in mails. So here in the traditional model, how we would have worked before is we would have provided the mails and some rules to check whether it's a spam or not, and depending on which, on the rules, we would get a output whether it's a spam or not. So to detect the mails, spam mails, we can write a word like congratulations or hurry or something like that, and we would require to write that things or hard code that things in our code. That was our traditional approach. But what happens in AI ML is we just provide them the bunch of mails and the output, like the mail one, and it has some body, an index, and the output of it, whether it was a spam or not. So by providing a bunch of data to the system, it itself create a rule and give you the predicts you the output whether the new mails that it can get will fall in spam category or non-spam category. So in short, like this is what AI do in real life. So now, if we talk about the data, one of the things that AI needs is a bunch, like plethora of data to start with, because it needs to train itself to make that rules that earlier humans were applying it to the machine. Now, to create by itself, we need to provide that data to it. So the data size is obviously going to be very large, and nowadays we have seen with the advancement of the online services, the amount has already increased. Now they're even more, like we have billions and billions of data for smaller services as well. So intelligent agent is required to create that rules and look into that data and figure out what can be the output. Now obviously AI can deal with large amount of data in a quick time. Like our CTO was telling, we have built a system which can work with 8 billions of data in just 10 minutes. So it can be possible with this technology only. We have now cloud services to use. So this is one of the very important criteria in AI building, AI and ML algorithm building approach. So to hold all that huge data in some space, which can be our source, and then doing the calculations on top of that data, we require these cloud services. So this is one of the real-time problem that we have solved. So the SE is a electricity providing company, and they have millions of poles, electric poles over the California region. So what they require is to prevent any hazardous actions in future due to fires. So they need to go to each poles and check whether they are in a good state or not, or if they require any changes to be done, or any equipment needs to be replaced with the new one. So all that things needs to be done. So to help them, what AI is doing here is it analyze the quality of the pole with the help of images provided by them and make the predictions. So using this predictions, one can make a judgment like which poles needs to be addressed right now, or which are in healthy states. To handle the situation, we have built many detections model, where one of the model is blurriness, and one of the model is occlusion detection, where actually we are detecting if any tree or dry bushes are around the pole. so that it can be like we can cut it down, or we can make the preventive steps to cause any emergency situations. So this is one of the real-time problem that I'll be showing you through the demo, like how it works. So yeah, uh, so today I'll be talking about one of the AI platform that is provided by Google, and it is called Vertex AI. So in Vertex AI, we get a unified platform where you can store your data, and you can also deploy and use it externally. So at one place, this is a unified place where you can start from the data ingestion till data annotation and model building and deploying it. So all the steps can be done in one platform. So also we have a few ways to train it, like auto ml, and we can use custom training as well. But auto ml helps the person who is going to train, even with less knowledge, they can train a model, build a model, and use it in their further computations. So this provides this end-to-end integration of all the data and AI platforms. So this is the chart which shows, like here you can see all data readiness, feature engineering, hyperparameter tuning, model serving. This all things has been done by AutoML. So one who doesn't know much how to do feature engineering, or which model to use and how to make a judgment which can be a good model while developing it, or for that matter, if somebody doesn't know how to develop a new model, then they can go for AutoML and check their performances. And again, if you want to check how particular model will perform on one set of data, they can also go to AutoML and check the initial outcomes. And then after getting that initial results and the inferences, they can go back and choose their custom models as well. So a few of the technology stacks that we have used to build the demo workshop is the Google Cloud, Google Cloud Storage. It's the bucket where we store data. Vertex AI to train our models and deploy it. Python to code the predictions and inferences from the results that we are getting from AutoML. So at the start, when you get a requirement from the client, how does we start working with that requirement? So initially we try to understand what is expected out of the model. Like in the real-time problem that I am talking about is, we have to prevent the any fire hazard issues. But to do so, we cannot directly use AI/ML to predict if there is going to be a fire or not. There are some steps that needs to be built while designing our model, I can say the platform or the system that we are going to deliver. So first, what we do is we collect the data. So to collect data, it can come from the various sources, from microservices or any applications, web applications. It can be residing on various platforms. To collect that and put it into cloud storage, like GCS in this case, or Azure, or AWS, or any services to store that, we need to get the data from there and store it over there. So this phase is initially where data engineering comes in the picture. They extract the data from the data sources, and they transform it in a readable, or I can say the structured format, and put it inside the loaded inside some containers, from where we can take the data and start building our models, and making the to start the model as well, we need to do a lot of work. like data preparation to start giving it to the models so that they can understand. So every model like has some limitations, like we cannot provide any text data to it, let's say. So for that we need to make um, them into a numerical value, or we sometimes needs to normalize them and then give it to the models. So after we do all the data preparation and training and evaluation part, we store the output with our predictions and the model files into some data warehouse, and from there we can use that data to prepare any dashboard or presentation, so which can be useful our business executives, because giving just the data or the numbers will not be useful for them to see the patterns in how things are going, and how are, like, let's say any customers reactions are going with the any product, or during the time how it is changing. So to tell all that story, we need to present the data in a presentable format. For that we can use any tools like RBI and Tableau to make the dashboards and share that with the direct users, so that they can understand what the data is saying actually. So the same pipeline I have explained over here. So this is one of the very important steps to start with the data, to collect it and store it in a structured format. These three steps are required over here. So data can be in any format as well. It can be in a JSON format, or any we can get it from any using REST API. We can call it from any sources, and we save it in some place that act as a source of truth to us to start with it. So these three steps are mainly dealing with the extraction, transforming, and loading the data, which can be used for ML or any deep learning models further on. So computation is where we do actually we where all the AI things happens, where we collect the data and do our analytics to identify or to understand the data better, and what can be applied to that to get the output. So all that calculations are done over here, and in the presentation layer we deliver it to the clients using the dashboards or some email notifications like that. So as I said, the first three steps are majorly what data engineers deal with, and then we have this data science computation layer, where we collect the data from data warehouse and do our initial data analysis, where we understand what kind of data we have. Then this can be done using like by plotting various graphs to understand the pattern and to see the actual data, how it looks like. We can do univariate analysis, multivariate analysis, where we'll check two or three features at a time and see how things are related or correlated to each other. Then moving on, after we have enough knowledge about the data, we go to the data preparation part, where we do some transformation with the data, which is required to move further. Like one of the example that I said is the text. We cannot use text in a model, so that needs to be replaced with numbers. There are many techniques today do it, like in text analysis, we create bag of words or embedding. So there are so many things which can be used over here to do all these kind of transformation. Simply, if we have like in our data, because it's a real time data, we we cannot expect it to be in very good quality. To improve that quality, like sometimes we may not have data for all the features that we have, so we sometimes needs to impute something as per the business domain. We can make the decision what can be imputed over there. Sometimes we need to do some data cleaning where sometimes there are some outliers which can totally change the meaning of the relations between two or three columns. So that anomalies needs to be avoided and needs to be removed from the data. So all that data preparation needs to be done over here. And to emphasize more, I would say that data preparation and transformation and data loading and analysis of the data, this requires the majority of the time for the data scientist, because once we have a cleaned and a nice data to work upon, then our models will also perform well. Otherwise, sometimes what happens, we just keep on trying different algorithm and it doesn't work very well. And the reason could be the data provided to them. There can be if some outlier is there, simply it can completely distort your predictions, because sometimes it's going, suppose um, um, there is an age factor, and we are dealing with somebody with 20 to 50, and there are some records with the similar feature values, and their age is suppose 80 or 2 years. So it can, it can be difficult for the model to understand it. So to get the better result, first step for us is to completely understand the patterns that the data is following, and to prepare it in such a way that models can understand it well. So after we have the data ready, the complete data ready, we go for the model development part, where we try multiple models. Like even if we are doing any small things, any any classification algorithm, if we are um opting to write, then we need to write few. Like we can go for random forest, logistic regressions, or any XGBoost, suppose. And because why do we write? We need to create multiple model is in in one go we cannot get the best model. If suppose on one set of data there is a, um, a model which is performing well, or maybe let's say 80% with 80% precision, the other model can be a better performer on the same set of the data. That's why we prepare multiple models, and then when we do the evaluation of the model, then we decide which of them are performing better on particular data set that we are using. So after we develop like few 4 to 5 algorithm, and sometimes we need to create the ensemble of algorithm as well to get the best output. So this is what this also happens in real time when we get to merge 2 3 algorithms in a one. The model validation is the step when we check the performance of the model on unseen data. So what happens in, we divide our data set into 3 categories, where train, test, and validate. So the train data set goes to the training part, on which the model is already trained and it has seen all the data and trained itself. Then we have this validation set, where we can check which is new to data, to the model, and the model has not seen it, and depending on the performance on those data set, we can tell whether like in there what we check is there should be not much variance as what we saw with the trained model prediction and the new dataset predictions. So to check all that variances, we create this validation set and test our models on that. Evaluation is when we um, check our model based on various performance matrices. So there are many, uh, like accuracy, precision, recall, sensitivities, and there are many like F1 scores. What we try to do is to gain as much as accurate model that can be possible. And why we have multiple performance matrices, there is a story behind it. If I talk, if I have used any model and it is performing like 90% accurate or 99% accurate, it doesn't mean that our algorithm is so good that it is predicting everything correct. It can mean that in our training set we have provided all the positive classes and only once it has failed out of 100, let's say, and that's why it's showing 90% accuracy. So to do to remove this confusions, we have this particular matrices that we consider along with the accuracy of the model as well. Accuracy cannot give always you the true picture to you, so that's why we need to have the um, recall values which can tell like how out of all the positive classes how many positive are getting predicted, and the precision like total how many false negative classes has been identified correctly or positive classes has been identified correctly. So after we have the model ready with us, we go to the prediction layer where we create a script that can call our models, that can we provide the model files, the PV files or H5 files to this prediction script, and we can infer from the model files and use that model file to predict from by giving any input to it. Once this is all ready, we go to the presentation part and show what the outputs that we are getting and how accurate it is. So these are the layers, and few of the items that we cover inside each layer is firstly in data exploration part and model development. First thing is to collect the data and understand the need clearly. And there are two types of requirements, I would say. One is the business requirement, and then is the respective technical and requirements that we need to, as a data scientist, we are supposed to also make that requirements by ourselves, which can meet the business needs. Then to have this happen, we need to create various algorithms, and to decide which algorithm can be used for each particular problem statement is also an art, where we can write various algorithm and decide which is which all things like simply if I would say as an example, classification means classifying anything into one category, but sometimes we also get in um, real-time problems where classification is one object can be classified as two things and three things or maybe four things. So these are some two different kinds of use cases, I would say. One is where let's say I'm identifying from a picture, I'm identifying whether it's a dog or cat, so the output can only be a dog or a cat. So this is one of the classification. And suppose if I'm identifying in a picture, I am trying to find out uh, animals, and there are also some other features, or whether in if I talk about the text data, then maybe one, like let's say example one can fall, can be done using two things, or let's say it can have two outputs as well with different confidence scores. So that is something else. So we have different, like if I talk about the deep learning part, the activation functions are the one who are responsible for making the judgment whether we need one output out of all five categories, let's say, or we can have five categories at one, or combination of them is also possible. So the real-time problems can change, and the questions and the requirements can be something which needs some changes or tweaks in the existing models so that we can deliver the output that is required. Then after we have the algorithm ready and we have validated it, this is not it. It's an iterative process. We need to like try multiple times whether it's performing, like whenever there is like a new data set, as in it's not completely new, but we are seeing something different, some new category has been added to it. At that time we need to reiterate our model and do all the steps and do the experimentations on that, on top of that data as well, to maintain the accuracy of it. So this part is where we build the data, we reiterate, we develop it using multiple algorithms, and we identify how the data are related to each other and in which way they can perform the best. And then after we have achieved the good results from the data, we reaches to the stage where we train our models. And this is one of the step where we required lot of historical data, and we do some exploration on this, and then we start our iterative model to train on the data set. The train model then needs to be deployed to somewhere so that it can be used for further downstream steps. So depending on the cloud platform, we can deploy it to anywhere, like whatever we are using we can go and deploy over there. So in this particular demo I'll be showing you using the Vertex Ai how can you deploy. So the next is the demo. We'll go over each step and how we did in the Google platform. So the first step is to collect the data from here. We'll be collecting it from the Google open source, and then we'll show how to annotate it in the Vertex AI and prepare our data. So after we prepare the data, we can train it using AutoML, or we can build our custom models as well. But we'll show you using the model built by AutoML for the demo purposes. And then to import that data and deploy it to one endpoint, we'll show from where we can go and do that. And then we have created a script which can show you the output from that models. And this is the flow that our current demo is following. So to start, we have collected the data, then we are detecting the electric poles from it and preparing the data set, saving it to the GCS, and then we are calling our model which is going to identify the pole. And if we find the pole, then we do our occlusion and blurriness calculations and print the results. And if we don't find any poles on that picture, we can simply ignore that image. So about the steps, I would like Ipchita to show you how can we download images from the open source using this extension. So, Ipchita.
Yes, can you hear me?
Yes, Ipchita.
Is my screen visible?
Yeah.
It's visible.
So for this demo purpose, we collected the data using the image downloader extension. But in real life, you are going to get data from the real world. So as ma'am told at the beginning, we get around thousands of data every day regarding the electric poles. But for this demo purpose, we have downloaded it using this image downloader. So after downloading this from image downloader, what we do is to upload these data into the Vertex AI dataset platform. So over here, you can see that there is a dataset named electric poles. So we see that. You will see that there are around 2040 data that we have stored in this dataset. And we can label this using the same platform. So some of you were asking that what is labeling data. So I'll just show you how we label data. So for example, this image I'm taking. So over here we can see that there are two electric poles. So labeling of data, generally annotating means that we need to label the data. So I'm just going to draw a bounding box around this. And I'm going to say that this is an electric pole. So this is essentially known as annotation of data. So we are telling the system that this is a picture and this is the place where the data is stored, or this is where the electric pole is stored. So yeah. So the next step will be to give it to models, which Neha ma'am will show.
Yeah. Is my screen visible?
Yes.
Okay. So as shown by Ipshita, we have labeled this data from here, and annotation and labeling are the same, and this is the part of data preparation. So to start with the model training, we need to have the data, and for each images we added the images into this folder, electric pole, like 2000 images are there, and you can see that some of the unlabeled images are also here. So these are raw images, and one needs to label it for the model training. If it is not labeled, it will not go to the model training. So to label, like she showed, we can go and put a box. And what our models will do now, whenever they find any edges like this in the new image that we will provide to it, it will try to detect this area. This is the bounding box that we the green color box that you're seeing over here. This is the bounding box, and our model is will be trained to predict this bounding box on any new image that we'll provide. So to start to train, we can go and click on the training model, and here you can see that there are three methods that Vertex AI provides you to train. One is the auto ML, and this is the this doesn't require any efforts or any expertise. You can just go simply and continue. It won't ask any algorithm to it. Internally what it does, it work on the data, and it uses the same algorithm that we can build as well, and try to find the best algorithm that is performing best on the particular sets that we have provided. And this is another training method that is limited to the on-premises uses as well only. And the third model, that is custom training. Here we can run our own models in the cloud and train, and we can prepare the uh, one of the images of that model that can be used. We call it as a container, and that container can be used to deploy further. So here we can write our own models as well. So in our real problems that we have done it for the company, we have created our own custom models only. Why I'm saying this, why this is one of the auto ML is for somebody who doesn't have the expertise on the algorithm and doesn't know if we are getting low recall, then what needs to be changed. If we're getting high bias, then how can we change, make tweaks in the algorithm and improve it. So auto ML can give you the first experience and first look at the data and how it is going to work. But to get the better accuracy, the one that we have created using faster RCNN is performing better than auto ML, and all our custom models that I have built so far has performed better than the auto ML models I have seen. So this is one of the custom options that we usually go for training. But for the demo, we have chosen this AutoML because it's quick and it can be trained in a less time as well. So moving to the next, once we train it model, it will take some times depending on the number of images or number of data volume that we are providing. It takes some time to train, and once it is trained, you can see all the models inside the models here. So like we train 4 models on top of this, and let me show you one of the models as well if I can. Right. I think I can show it from here. So this is one of the AutoML trained model. So you see that we have different classes over here. Electric pole is one of the class that we need to identify. The other two we classified into some different categories like graphical images. Some images we took from the internet that was not the real electric pole images. There were some graphically drawn pictures. So we have segmented them into different class, and few pictures doesn't have the poles, or they have people with the poles, so we have classified them into this category. So if we go, this is our positive class over here. So electric pole, you see there are some these are the, this curve is showing the performance of our model, this model that we have trained. And you see that on confidence threshold 4.7.47, the precision and recall, the respective precision and recall. So what the threshold is, the output that we get from the model is always between 0 to 1. It's a probability. So the 0.50 means it has 50% probability, and we have kept this probability. We can go and change and see on which it is performing best. So one of the key points over here, how to choose which threshold we should keep to get the best model. So we should always try to keep uh, precision and recall as same as possible. Why is that? To explain that, I would like to tell you what is precision and recall. We need to understand that first. So precision means, suppose we have 10 images and 10 values, and out of that 10 we have 8 true values and 2 false values. Then precision means, out of 10, like we have identified, let's say, 6 correct values out of them, so the precision will be 60% of it. And recall means, out of that 8 positive values, how many of them has been classified correctly. Like suppose I have classified 5 true values from there, so it is 50%. So if the precision is very high, that means out of all the data, the true values that has been identified correctly, or the false values that has been identified correctly. This can be explained better if I go to this confusion matrix. So here you see that these are the actual values and these are the predicted value that we have got from the model. Suppose the first one says true positive, that means actually it was true and identified from the model as also it's a positive class. The second shows it was a false value, and from the model has said that it's a positive, it's a true value. The third is false negative, and the fourth is true negative. So I have this example written here to understand it better, like what is true positive, what is false positive and all. So suppose there are men and women, and if the model is saying that a woman, particular woman X is pregnant, that means it's a true positive, and because she is pregnant and a woman can be pregnant. True negative means the model has said a man is pregnant, and in actual, you know that this cannot be true, so this is false, and the model has also predicted it as false, so this is true negative. This also falls into a uh, I would say the correct category. If you will find the accuracy of the model, you sum up the true positives and true negative divided by the whole data set. Because this is also the correct prediction that we get from the model. True negative means the negative class has been identified correctly. False positive means the man is not pregnant, but the model has predicted it as a pregnant person. So this is like the prediction from the model is positive, whereas the actual value was not. So this is false positive. So this we try to reduce as much as false positive as possible. And false negative is when the pregnant woman is said that she's not pregnant. So this is the false negative, where the prediction is saying it's not pregnant, and the actual result is she is. So this is how we collect our prediction results, and we try to analyze like what is failing and how it is failing, and what needs to be improved. So depending on the threshold, as I was showing, you can go and check, like on each threshold you can find different values of precision and recall. Like if I go to this point, if I keep threshold as 72%, that means like above 72 we are calling it as a negative class, or below 72 we are calling it as a positive class. So that's how we divide the uh, classes. Like if the confidence score is more than, let's say, 72%, then the particular object interest area is electric pole, or else it's some different class. That's how we are going. So we have kept 0.5 to get the best of each precision and recall value in our models. So showing you the model over here, we have this model being trained, and this one is deployed already. So to deploy any model, it can be done using the UI, or you can also create a Docker file to deploy it. But here you can simply go to deploy to an endpoint, and you can define any name which you want to. You can put any name, and then you can continue and set the instance parameters over here. So this endpoints means a virtual machine on which your model will run. So you will import this model to one machine which is provided by cloud platform, and whenever you call your model, it will run on this machine. So because as you know that our ML or TensorFlow models are they usually require GPU along with CPU to execute. So we can tell any like specifications over here, and we can select the GPUs as well, and go on and create or deploy a model. So like if I go on one of the deployed one, and yes, it charges some. This is the endpoint. It costs you some dollars to deploy or use or train any models. So this is the endpoint. And here let me show you the sample request how to call. So this is the endpoint, like this is related to this example only. We are getting the endpoint ID, project ID, and the input to which can be provided to this. So now if I go at like how to use this endpoint that we have created after training our model is we can go and create a Python script. It's inside the workbench. We can create any Python notebook or the ID over here. I'm using Jupyter Lab, and I have this code written where, like in get prediction, I am calling our object detection model. Like here, we are providing the endpoint details, endpoint ID, location, and path. The threshold that we are going to, we can make changes from here as well. And we are calling our method over here using this endpoint that we just created. So if I show you the first example how it runs is, this is the original image that we provided to the model, and this is the annotated part that we got. So the image has this bounding box, and in the output of the object detection, you can see this is the output from the object detection model. You can see the IDs to just keep the index of it. In confidence is the score, like 0.95 means the model is 95% sure that this is an electric pole. Like you see that there is the display name is electric pole with the confidence score 0.95, and this has the bounding box. This holds the pixel values, like these four coordinates values, and this can be used for the further processes, like we are running occlusion and blurriness on top of it. And what each of the model is doing is, in occlusion, what we are identifying is we are providing this region because this is our area of interest in this picture. So we are providing just this part, cross arm part, and where we are seeing the wires. We are providing this object to our next models, and the occlusion model, what it is identifying is it's checking if we have any um, trees or bushes around this pole or not. So here you can see that it says not occluded because we have like created a TensorFlow model, and we have used one pre-trained model mobile net to identify this, and we have done our training where we have given some occluded image to the models and some non-occluded images. Like this image, if I show you, this is an example of an occluded image that we have passed to our model, and the model is identifying this as occluded as well. So whenever we see any leaves or bushes around the pole or wires, we have marked them as a occluded images. So in our training, when we were building the data for like where we were labeling it, we have marked these kind of images are occluded. That's why we are getting the output as an occluded. And for blurriness, what we are doing over here is we are sending that area of interest to this piece of code, what where we are calculating the variance, and what we're using over here is Laplacian variance. And what it does, it divides the images into multiple grids, and we we move the grid, like out of like a complete image, we divide the images into, let's say, 3x3 images, and then we keep on moving and sliding it to one quadrant apart, and keep calculating the variances between the each pixels, and we get that variance, like how each block is different from the other block. Like if we divide this picture into small sections, like let's say this much area. So what we're trying to find out in this is if there are any changes in when we move from one cell to another cell. And it can be like we divided into the grayscale images first, and then we, whenever there is any edge, or there is any change in the codant values, which goes immediately higher or lower after that. So that is a variance that gets stored, and we calculate the mean of all the blocks that we can divide and calculate over here. And if the variance goes below some threshold, like here we have decided the threshold to be 260. If it goes beyond that, it's non-blur image. That means there is not the image is very clear. And if it is less than that, that means there has been more variations being done to that, and the image is not of that good quality. Like this one, you can see that this is also not blur. But if I show you one blur picture, so this one, you see that uh, this part of the pole is slightly blurred over here, and we have marked this picture as blur. And this is the object detection output, and we are passing the object detection output and this cropped image to the occlusion and blurriness model and making the prediction. And if the pole doesn't exist, then we don't call any other models, respective models, to do any calculations. So this one has no poles, so we have to simply said this doesn't have any pole, and we have stopped the executions over there. So this is the demo where we started with taking the input and calling our prediction model. Inside that model, we are resizing it to one size, because the images are of 11 to 15 MB, and it's a huge size image. So we resize them into a smaller scale, and then we call our object detection model on top of it. And then we get the bounding box, and using that bounding box, we are cropping the images and saving the cropped images to call the blurriness and occlusion on top of that cropped only that area of interest amount of picture, the this bounding box area. Only this picture is passed to occlusion and blurriness to tell whether we have the clear images or not. So yeah, this is what the demo is. And why we are doing this is, I would tell in one line to you, like we have identified which pictures were blur and which were not. So how it can help the business is, if the picture is blur, they can simply ignore that picture and move on to the other picture which is not blur. And their inspectors can go to each picture and see each equipment on top of the pole and make their judgments whether it is looking in a good state or not. All the conductors or wires or these devices that are on top of the pole, is it in a good state or not? So they can focus only on pictures which are not blurred. All the blur images, they can be excluded at one go. What it can help is, it can help the inspector to save the time to go to all the non-blurry picture which was irrelevant to them. And the occluded one, they can simply go to the occluded one and get the list out of all the like pole IDs which are occluded, and they can simply work upon those poles. And they can remove they can like, the non-occluded one can be passed down to the next level, where they check all the equipments on the pole. So this is how we can save the time and efforts, the manual effort that the inspector put on the images. And this is how AI can help them. and it does help like the the client, because in real time we get millions of pictures in a day, and to go through all of them is not possible. So the models can tell us, like suppose out of 10,000 we have only 10 images which are occluded, so we can focus on only 10 images rather than going to all 10,000 images. So this is how we can help. And yeah, so this one I have already shown, like this is how we annotate images, and we get the bounding box of it. Then blurriness is to get whether the picture is sharp enough or clear enough to look into each components of them or not. And depending on the variance code, we decide whether to uh, mark that as blurry or not. And internally, it, like I have written over here, Laplacian operator, it uses second derivative of the image. And this is where like in the morning I uh, saw one question about how statistics can help in data science or AI. So statistics plays an important role to understand many of the algorithms in depth. Like algorithms are built on maths and statistics. So to understand them clearly, because if you understand them, then only you can tube the last layers and make the changes. If you know how it is performing, then you can make the changes that you need for the real-time data. That's where you need to go inside the model and maybe make some changes in the last few layers, or if this is the case in pre-trained model, or if you are training from the scratch, then this knowledge of maths, probability and statistics can help you to make decision where and how you need to make the changes. Many of the algorithms has maths and statistics, like naive Bayes is all probability based algorithm that we have. This is one of the classification algorithm that we use. This Laplacian calculation is based on the statistics. So there are many which uses maths in background. So this is how Laplacian works. It takes a small area, and this image, like this is a representation of image. When we talk about the computers, we cannot pass the image as it is. We need to provide them into a numeric value, and each, like you see that this is a colored image, so the each cell value will be ranging from 0 to 225, but we need to scale down them. And uh, like to do so, we can normalize it, and we can use like normalization techniques or min-max scaler to scale down each of the cell value, which can range from, let's say, -1 to 1 or 0 to 1, whichever we want to, whichever way we want the data to be. And then we calculate the variance, which is the standard deviation of the responses that we calculate for each cell. And then depending on the variance, we can decide whether to mark this as a positive class or a negative class. This is the occlusion. So occlusion model can tell you like whether any if this pole is covered with something or not, if it is clear or not, if we can see all the equipments that we have used in the training of the images are being clearly visible or not. So we have used one TensorFlow deep learning model to predict the occlusion. And like I was saying, we built multiple models at once. This VGG16 is also a deep learning convolutional CNN model, and Deep CNN, MobileNet. These three are TensorFlow pre-trained models that we used to predict the occlusion. So this is how we decide which model to go for, and to use in the production, the final step. So This is where I show you here how to deploy it. And there is also one option like resume training. So Vertex AI can also help you, as everything is inside one place and this provide a unified platform. It keeps the model and data all together. So we can easily retrain our models as well with adding some new images, which is difficult when we are doing on our own machines or our collab notebook or any of Jupyter notebook. This is the functionality that cloud platform provides us to retrain in a better way, and it makes everything in a everything possible to be done in a quick and efficient manner. Then we have the endpoint settings and URLs, which can be used in our prediction scripts to call the model and tell the outputs. And lastly, I have kept some of the skills that is required to be a data scientist. And these are some of the must skills that one needs to have. Like, as I mentioned, maths and statistics is one of the important thing to start to understand any algorithm, or to start to know like what is going behind and how things are getting calculated or being computed inside the algorithm. Simply using sklearn dot preprocessing or this can help, but if you understand the libraries better, you can deliver better. Plus, statistics can also help to analyze the data. To you like we have some billions, trillions of data at once in real time. It's impossible to go to each records and see if there is any correlations between variables, or if something is highly depending on the prediction features or target variables. So to do so, we have various statistical tests which can be used, where we can take some sample of data and do a test on top of it and make the predictions for the larger data sets. So for that we need that statistical knowledge, and that's why it's a must skills to have for a data scientist. And then analyzing the data, again, it's a crux of data science job. Almost like 50 to 60 or 70% of the time goes into analyzing and modeling the uh, data that we going to give to the model, and then creating the data to get the inferences and insight from the data is very important. And this ability to analyze it better and model it better is a must for the data scientist. Then we have the skill where we go to the algorithm, decision tree, random forest, or any kernel, k-means, or any algorithm that we see in machine learning. It's the later on that we need to learn and understand how they work. Python or R, this is one of the most required skill, because everything you need to do in, like, if you need to, even if it is not a development job, you still need to program and use some basic programming concepts, like object oriented, and you need to know the Python or any programming language to code the DL or ML code as well. Then data visualization is another important aspect, where you break down your data and present it to the client, or for your understanding as well. If to to get the, like, it's easier to understand from a picture than a data. If we have, like, let's say 10 records to go it or go on each levels, and if it has 50 features, so it's difficult to go on check like what is the pattern that is followed. Rather, if we have any simple chart as well for the same, we can understand it in a better way. So that's why we need to have this data visualization skills too. And then The another important aspect is communication, and this is like data scientist needs to have the strong communication skills where they can like all the manipulations and transformation that they did, they should be able to tell it to the non-technical person who doesn't know how to understand the models and how to get out results from the model. They should also be able to relate and infer what you can see from the data. So it's a skill that is required, that you need to convey what the data is showing to you. So that is also one of the key important feature for the data scientist. This is it from my end. If you have any questions and answers, then we can go on.
Yeah, thank you so much, Neha and Ikshita. Very well done. Thank you so much for everything. Now we are opening the session for next 15 minutes for QA. And it's my privilege to introduce one more expert in our team. He is Pratik Ghosh, our senior data engineer. Okay, so Pratik, Neha, Ipshita, and Vishal are here. Next 15 minutes, we are opening the forum for questions. So answer to the question is the link that Pratik has given you. Nilaksh, that is our organization corporate website link, and there is a information how you can reach us. Yes, contact Third. Yes, thank you. Forum is open. Any questions, please? Attendance link, our partner Cognizant's IT Rootkit team will share with you. Don't worry, you will get it. This is part of the program. Okay, so there is one question. I'm reading the question for the subject matter experts. Anybody can pick it up. How does supervised learning differ from unsupervised learning? And which of them is given more preference when it comes to real world applications? Very good question, Rishi. How does supervised learning differ from unsupervised learning? And which of them is given more preference when it comes to real world applications?
Yeah, yeah, I'll go on, Kashmir. So supervised learning is this learning can be applied when you have the labeled input and output data. In the training set, if you have the outputs with you, you can use supervised learning. Whereas for unsupervised learning, you can proceed with unlabeled data as well. So for like the one that I showed you just now, where we were labeling it the electric poles and the graphical poles and people. So we were labeling that. So that is a kind of supervised learning that we did. For unsupervised learning, suppose you have some let's say some products and you want to categorize them into categories. Some is maybe shoes or mobiles, like that you want to create a category. So this is where you can apply any unsupervised learning as well, and like k-means work better in that category. And we have this depth scan. So these all kind of ml learnings where we provide the data set to them and they find out the pattern. If shoes are falling into one category, they'll mark them as one category, and the other set of data which has the same features, they'll mark them into one different category. So this can be like this kind of clustering can be done using unsupervised algorithms as well.
Thank you, Neha. About the internship, that will be the last 15 minutes, which I will talk about. Okay, I'll come to that, Aman and everybody who has questions about intern. So that's a dedicated 15 minutes I will spend on hiring and the intern. So that will be taken care of. There are a few other questions. Let me take those questions. One question is about, what was that? Can we do image processing in AI without an external GPU?
I don't think, because we can do, I guess, for few images, but whenever you go beyond like 100 images, or if you try to build any good models, you won't be able to do it without GPU. And firstly, you need to have GPU to have this TensorFlow installed and for all the settings. So GPU is required. In Collab, you get the free GPU for, like, I think some few instances you get. So maybe you can try from there.
Sure. There is a question from Sanskar. Any YouTube link or any blog link which explain the above with proper code implementation? Yeah, there's many. There is many actually. You just type with any of these object detection or any IML topics. You will give a lot of inputs. Okay, and the three major cloud giants, AWS, Azure, and Google, they have a very good documentation, right? You just search for it, it is available. Okay, there is one question. How can we increase the accuracy of our ML model without much of alteration in the dataset?
Maybe you can add more data. This is the first thing that you can do, but this cannot work every time. You can add more data when you see that there are more bias in the data result. But if you want to increase the accuracy, you need to go back to the data preparation steps, where you do the data preparation and transformation and make some changes over there, and then only you can increase the accuracy. But one thing that you can try is, obviously, if you don't want to go to that step back, you can try including more data and positive results too.
Okay, thank you. Two more questions came. One question is from Ankita. How can we increase the training part for accuracy increase? I think she's talking about model training.
Okay. I didn't get the question.
Okay, the question is, can we increase the training part for accuracy increase? I think she's talking about.
By training part, do you mean the data set, training data set? Yes, we can increase the training data set to increase the accuracy. That is what I meant.
Thank you. It's a very good question again. There is one more question. How much data set is the minimum for OCR image processing in AI?
For in-house, maybe you can start with 200 to 300 images for now. But yeah, if you are building any real-time images, then I would say that you need to have like 3,000 to 4,000 images to get better performances. And we have this site Kaggle. If I am sure you must be aware of it. There are many questions and data science problems over there, yes, you guys can go on over and take any examples and start practicing the AIML algorithms over there. They provide you the platform to write the code as well. They have the data set also. You can download from there and build our models and check your accuracies over there. So it's a good platform for learning.
I think you answered that free data set, no? Yeah, right.
Yeah, free data set, yes.
Right. Pratik, am I missing any other question?
Somebody is asked about one question we have missed, I think. Yes, Ram asked something like why the development of AI ML is not significant in defense sector, particularly in context of India, since I see it is mostly focusing marketing and services, etc. No, it's not like that, buddy. If in the defense sector there is something is working on AI and ML, defense sector will not disclose to us, right? But it is going on there because if I give you example, something like that, if you see about the drones or the IoT systems, it collects the data, right? So after collecting the data, it do some AI ML processing on that. So it is really doing a much on that field.
Thank you, Pratik. Let me take this question. Is this certificate really worth? Yes, it is, because it confirms that you have attended a workshop on AIML. Okay, so I'm sure whatever you have heard, okay, a little thing even that will help you a lot way going forward. So everything is useful. That's all I can say. I have this last section, then I will talk about it a little more. Rishik, you are right. Thank you so much. Rishik is saying defense sector is implementing AI in India too. And it's one of the most important sphere where it can be applied. Okay, we'll take two more questions. So Ankita has a question. Ma'am, is there any cross validation in ML?
Yeah, we have cross validation, and it's one of the best method to detect any if model is overfitting or not. So what we do is we divide the data set into various subset and evaluate our model on top of it. So yes.
There is one question, if you can take this. I think there is CPU and GPU difference somebody has asked.
Yeah, you have missed that. Yeah. So what you know about the CPU? It is actually designed to handle the wide range of tasks quickly as measured by CPU clock. But when you go to GPU, that is for the quickly render of high resolution things like images or video as in a concurrent manner. Okay, so the processing is more fast there than CPU.
Thank you. There is a question from Ankita again. Ma'am, what is overfitting?
Okay. Overfitting is Ankita, when you train your model and you are seeing all the performance like accuracy as suppose 90%, and this 90% is from the training data, and if you pass on any new data which the model hasn't seen any time, the test data, and you see that it on that test data it has performed like let's say 40% or 60% or 70%, any like if you see a huge difference between the accuracy of on the test data and the accuracy on the training data, that is where you see that model is overfitting. Thank
All right,
you.
very good. So I think we have all the questions answered. So thank you so much, Pratik, Ipshita, Vishal, and Neha to support in this. Now we almost came to the last segment, which I will take over about the hiring and internship. When the certificates will be issued, this question is asked by Syed Rizwan. Rizwan, our partner is Cognizance IT Rookie. They're taking care of it. Just don't worry, you will get it. Okay. So there is a process, there is a form, okay, and you will get it. All right. So thank you so much for your participation and presence. And now we're coming to the last segment. Okay. So let me share my screen and take you through. And it's just last 15 minutes. I'll be supported by our HR manager, Purnima, on this. Okay. So before I start, let me quickly put 2 links in the chat. Okay. One. Careers, no? I have given. Second one. Okay. Here you go. The second one. Okay. All right. So let's come to this. You're able to see my screen, right? So we have ample opportunities in Third Eye, and I shared the corporate link with you, and Pratik just did it also. Now, if you click one of the link, these are the open positions that we have, right? And you have to see there are a lot of open positions across multiple domains, right? Senior data engineer, cloud data engineer, Scala architect, right? Azure data engineer in Hubli. So recently, we are going to open a new office in Hubli, Karnataka. Some noise is coming. Can you put yourself in mute?
Yes.
Thank you. So we are going to open a new office in Hubli, Karnataka, and we have open positions for that too. So I would sincerely request all of you to share this information with your friends, colleagues, relatives, okay? And I have given you the link. The link is accessible for you. And these are the open positions. Go inside any link, okay? I will just show you right now. You will see a job description, okay? So there is a job description, a brief description of the responsibilities, the requirements in terms of the technical skill set, what is required, right? And you can just click on I am interested, and that's it. We will get the information, okay? So this is about the hiring opportunity. Please use it. And the second one is for the internship program. Yes, I want to focus a lot on this because I know many of the participants on this workshop, they are from different engineering streams, and I'm sure they're also coming from 3rd year and 4th year whatsoever. So Third Eye has a very strong and comprehensive internship program, which is 3 months long. Okay. Predominantly, we are looking at 3rd year engineering because this has been our experience with the placement officers from your colleges and universities, because there is 6th semester, I think, when you get time and you can participate in the internship. And our internship is really detailed. And in these 3 months, we train you. And as you have already heard from the morning, that we have subject matter experts from data science, data engineering, and DevOps, right? And we train our interns on those domains. We call it a learn and earn professional program. Why? Because we give you training, okay, and we also give stipend. That's why it's a learn and earn. After 1.5 months of training, we will expose you to some projects, customer projects, okay? And there are a lot of projects we have in hand where you can participate, you will have hands-on, you'll get exposure, practical exposure. What is our real focus? Our real focus is that you become data professionals. Next 3 to 5 years down the line, the IT will be going to be ruled by data. Okay, that is why we focus too much on data. And everything that you have heard from the morning till now, it's all about data. Now, what is the ideal candidate criteria? The most important criteria is can-do attitude. Okay, that is top notch, number one. Other than that, let me show you this page. Sorry, I'll just zoom it a little bit for you. Basic computer science skills, some basic programming skills, and basic data skills. That's all we are looking at. Exposure to cloud is good to have. But the reason we have been saying that basic because you are the beginner and we are just expecting you to have some basic insight. Okay, rest we will take care of it. I will change it a little bit. Okay, what you need to do, you just need to click on I am interested. That's it. Okay, so I would sincerely encourage all of you, use this link and click on I am interested, go through it in detail, right? Be in touch with us and we will share all the inputs, whatever you need. Saying that, I also want to invite my HR manager, Purnima, for some comments from her side.
Good afternoon, everyone. It was a nice session to have. Thank you, everyone. Thank you, TJ, Aprajita, Vishal, Pranav, Prashanjit, Ipshita, Neha, Pratik, everyone. Thank you so much. It was really a very informative and insightful session that we had in collaboration with IIT Roorkee. Thank you, Roorkee, for providing us this platform wherein we could conduct this. And thank you, participants, for attending this. So as Prashanjit has already mentioned, that we are hiring for lots of positions for both Kolkata and Hubli. Yeah, we are having these positions open. You can go to our website, open the hiring page and apply for whatever is suitable for your skill sets and your area of interest. So I believe that most of the participants are students. So you will be more keen towards going for internships. So yeah, you can apply for internship in the I'm interested button. You will get the form to fill a few of the details and you need to upload your resumes. And yeah, therein it will reach us. Our talent acquisition team will then reach out to you. And yes, we are providing stipends to interns. And if you do really well during the internship program, then you might as well get hired as full-time employees. So that is the best part of it. So it's not only about internship. So you might actually end up landing the job in the upcoming booming technology, which is going to be the future of IT. And rather, not just the future of IT, the future of mankind, I would say, in each and every sphere. Yeah. So like if you have any questions for me, you can ask. Aditi, I guess you are on mute. We cannot hear you. Hello.
So let me say one thing. Thank you so much. Sincere gratitude to IIT Roorkee Cognizance team for your wonderful support and all the participants who took time out on a Sunday, joined, and we are very excited and happy about it. Hope it helped you a lot. And last but not the least, Third Eye team, right? Everybody, Vishal, Neha, Ipshita, Pratik, Prithvish, Purnima, thank you so much for all of your contribution and sincere gratitude to all of you. Take care. Aditi, from the IIT Roorkee side, if you want to close it in your way.
Thank you so much, sir, and the third editor team. It was really a nice session and also a great pleasure to meet you all. And as this is online, so I also wish to meet you all offline too, but I think this is not possible. And also thank you so much for the opportunities you have provided to the students and to also us. And we would love to get another workshop also next year by the third eye data. Thank you so much.
Yeah, and we are also excited and we are enthusiastic to have a partnership, long partnership with you, of course. And thank you so much for your backend support and everything that you did for the last couple of weeks. And it's just wonderful.
Yeah,
thank
it's
you.
Very much pleasure to us also.
Okay, so take care, everybody. Stay safe, stay healthy, and have a wonderful rest of the afternoon and evening. All the best. Thank you. Bye.
Thank you, everyone. Bye.
Thank you, everyone.
Thanks, everyone.